Dear students, today I am going to discuss about the general paper of the chemistry for the CET and NEET exam. Okay. Do you know that? Nodi, in chemistry alli total agi first year alli 9 chapters and in second year alli total 10 chapters, total agi 19 chapters ide. ನೀವು ಒಮ್ಮೆ ಯಾವ ತರ ರಿವೈಸ್ ಮಾಡಬೇಕಂತ ಹೇಳಿದ್ರೆ ಈಚ್ ಚಾಪ್ಟರ್ ಬಗ್ಗೆ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಫಸ್ಟ್ ಇಯರ್ ಅಲ್ಲಿ ನೀವು ಯಾವ್ದೆಲ್ಲ ಚಾಪ್ಟರ್ ಅನ್ನ ಸ್ಟಡಿ ಮಾಡಿದ್ರಿ. ಓಕೆ, ದ ಫಸ್ಟ್ ಒನ್ ಇಸ್ ಸಮ್ ಬೇಸಿಕ್ ಕಾನ್ಸೆಪ್ಟ್ ಆಫ್ ಕೆಮಿಸ್ಟ್ರಿ ಲೈಕ್ ಸ್ಟ್ರಕ್ಚರ್ ಆಫ್ ಆಟಮ್, ಕ್ಲಾಸಿಫಿಕೇಶನ್ ಆಫ್ ದಿ ಎಲಿಮೆಂಟ್ ಅಂಡ್ ಇಟ್ಸ್ ಪಿರಿಯಾಡಿಕ್ ಪ್ರಾಪರ್ಟೀಸ್ ಲೈಕ್ ದಟ್. ನೋಡಿ, ಈ ಯೂನಿಟ್ ಅಲ್ಲಿ ಒಮ್ಮೆ ನೀವು ರಿವೈಸ್ ಮಾಡ್ಕೊಂಡಾಗ ಆ ಯೂನಿಟ್ ಅಲ್ಲಿ ನಾನು ಏನನ್ನ ಕಲ್ತಿದ್ದೆ ಯು ಕ್ಯಾನ್ ಬಿ ನೋಟ್ ಡೌನ್ ಇನ್ ದ ನೋಟ್ ಬುಕ್. ಆಯ್ತಾ, ಈಚ್ ಯೂನಿಟ್ ಗೆ ಒಂದು ಸಪರೇಟ್ ಪೇಜ್ ಅಲ್ಲಿ ಯು ಕ್ಯಾನ್ ಬಿ ನೋಟ್ ಡೌನ್ ನಾನು ಏನನ್ನ ಕಲ್ತೆ. Like that, you have to make the concept or the objectives for all the 19 units. ಇದೇ ತರ ನೀವು 19 ಯೂನಿಟ್ ಗೆ ನಾನು ಏನನ್ನ ಕಲ್ತೆ ಆ ಯೂನಿಟ್ ಅಲ್ಲಿ ವಾಟ್ ಆರ್ ದ ಇಂಪಾರ್ಟೆಂಟ್ ಫ್ಯಾಕ್ಟರ್ಸ್ ಆರ್ ವಾಟ್ ಆರ್ ದ ಇಂಪಾರ್ಟೆಂಟ್ ಆಬ್ಜೆಕ್ಟಿವ್ಸ್ ಇನ್ ದಟ್ ಲೆಸನ್. ಆಯ್ತಾ, ಅದನ್ನ ನೀವು ಒಮ್ಮೆ ಮಾಡ್ಕೊಂಡ್ರೆ ಅವಾಗ ನಿಮ್ಗೆ ಒಂದು ರಿವೈಸ್ ಆಗ್ತದೆ. ಅಂಡ್ ಆಲ್ಸೋ ಯು ಮೇ ನೋ ದಟ್ ನಾನು ಈ ಯೂನಿಟ್ ಅಲ್ಲಿ ಏನ್ ಕಲ್ತೆ, ಹಾಗಾಗಿ ಈ ಯೂನಿಟ್ ಅಲ್ಲಿ ಏನೆಲ್ಲ ಆಬ್ಜೆಕ್ಟಿವ್ಸ್ ಇದೆ ಆ ತರ ನೀವು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಬಹುದು. ದೆನ್ ನೌ ಐ ವಿಲ್ ಮೂವ್ ಆನ್ ಟು ದ ಕ್ವಶನ್ಸ್. ಈಗ ನಾನು ಕ್ವಶನ್ಸ್ ಗೆ ಹೋಗ್ತೀನಿ. ಡೂ ಯು ನೋ ದಟ್ ಇನ್ ಸಿಇಟಿ ಎಕ್ಸಾಮ್ಸ್ ಹೇಗಿರ್ತದೆ? ಟೋಟಲ್ 90 ಮಿನಿಟ್ಸ್ ಡ್ಯೂರೇಷನ್ ಇರ್ತದೆ. ಅದರಲ್ಲಿ ನೀವು ಫಿಲ್ಅಪ್ ಎಲ್ಲ ಮಾಡ್ಲಿಕ್ಕಿದೆ. ದೇರ್ಫೋರ್ ನಿಯರ್ಲಿ 80 ಮಿನಿಟ್ಸ್ ನಿಮ್ಗೆ ಟೈಮ್ ಸಿಗ್ತದೆ ಫಾರ್ 60 ಕ್ವಶನ್ಸ್ ಅಟೆಂಪ್ಟ್ ಮಾಡ್ಲಿಕ್ಕೆ. ಯು ಹ್ಯಾವ್ ಟು ಮ್ಯಾನೇಜ್ ಇಟ್. The sum of the questions are in chemistry general ಆಗಿ ನ್ಯೂಮರಿಕಲ್ಸ್ ಕ್ವಶನ್ಸ್ ಸ್ವಲ್ಪ ಕಡಿಮೆ ಇರ್ತದೆ. ಇನ್ ಆರ್ಗ್ಯಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿ ಅಲ್ಲಿ ಕೆಲವೊಂದು ರಿಯಾಕ್ಷನ್ಸ್ ಅನ್ನ ನೀವು ಮಾಡಬೇಕಾಗ್ತದೆ. ಓಕೆ, ಅದರ್ವೈಸ್ ದ ಸಮ್ ಆಫ್ ದ ಕ್ವಶನ್ಸ್ ಆರ್ ಡೈರೆಕ್ಟ್. ಆ ತರ ನೀವು ಇದ್ ಮಾಡಿದಾಗ ಯು ಹ್ಯಾವ್ ಟು ಮ್ಯಾನೇಜ್ ದ ಟೈಮ್. ನೌ ಐ ವಿಲ್ ಮೂವ್ ಆನ್ ಟು ದ ಡೈರೆಕ್ಟ್ಲಿ ದ ಕ್ವಶನ್ಸ್. ದ ಕ್ವಶನ್ ನಂಬರ್ 1, ದ ಕ್ವಶನ್ ಇಸ್ ಲೈಕ್ ದಿಸ್: the which of the following complex has zero spin only magnetic moment? Do you know that? ಈ ಸ್ಪಿನ್ ಓನ್ಲಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೂಮೆಂಟ್ ಅಂತ ಹೇಳಿದ್ರೆ ಯು ಹ್ಯಾವ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟೆಡ್ ಬೈ ಯೂಸಿಂಗ್ ದ ಫಾರ್ಮುಲಾ ದ ಮ್ಯೂ ಇಸ್ ಈಕ್ವಲ್ ಟು ಸ್ಕ್ವೇರ್ ರೂಟ್ ಆಫ್ n into n plus 2. n into n plus 2 and the unit is Bohr magneton. Okay, that is the formula. ಅಂದ್ರೆ what is n? n ಅಂತ ಹೇಳಿದ್ರೆ ನಿಮ್ಗೆ ಗೊತ್ತಿದೆ, the n is nothing but the number of unpaired electrons. Number of unpaired electrons. ನಂಬರ್ ಆಫ್ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಹಾಗಾಗಿ ಯಾವ ಕಾಂಪ್ಲೆಕ್ಸ್ ಗೆ ಝೀರೋ ಸ್ಪಿನ್ ಓನ್ಲಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೂಮೆಂಟ್ ಬರ್ತದೆ ಅಂತ ಹೇಳಿದ್ರೆ ದೇರ್ ಇಸ್ ನೋ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್. ಅದರಲ್ಲಿ ಯಾವುದೇ ಒಂದು ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇರಬಾರ್ದು. ಇಟ್ ಈಸ್ ಎ ನಂಬರ್, ಇಟ್ ಈಸ್ ನಂಬರ್ ಆಫ್ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ನಂಬರ್ ಆಫ್ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದ್ರೆ ಅಂದ್ರೆ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದ್ರೆ ಯು ಆರ್ ಗೆಟಿಂಗ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೂಮೆಂಟ್. ದೇರ್ ಇಸ್ ದೇರ್ ಇಸ್ ನೋ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ನೋ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇಲ್ಲ. ಅದರ ಅರ್ಥ ಏನು? ಆಲ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆರ್ ಪೇರ್ಡ್, ದೇರ್ಫೋರ್ ದೇರ್ ಇಸ್ ನೋ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೂಮೆಂಟ್. ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೂಮೆಂಟ್ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನೋಡಿ, ಈ ಕಾಂಪ್ಲೆಕ್ಸ್ ಅನ್ನು ನೋಡಿದಾಗ ದ ಐರನ್ ಇದೆ, ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ ಅಯಾನ್, ಅಂಡ್ ಆಲ್ಸೋ ಕೋಬಾಲ್ಟ್ ಇಸ್ ದೇರ್, ಅಂಡ್ ಆಲ್ಸೋ ಯು ಹ್ಯಾವ್ ಟು ಅಬ್ಸರ್ವ್ ದ ಲಿಗ್ಯಾಂಡ್ಸ್. ಬೇರೆ ಬೇರೆ ಟೈಪ್ ಲಿಗ್ಯಾಂಡ್ಸ್ ಇದೆ. ನೀವು ಡೂ ಯು ನೋ ದಟ್ ಆನ್ ದ ಬೇಸಿಸ್ ಆಫ್ ದಿ ಸ್ಪೆಕ್ಟ್ರೋಕೆಮಿಕಲ್ ಸೀರೀಸ್ ಇಂದ ನೀವು ಹೇಳ್ತೀರಿ the which one is the stronger ligand, which one is a weaker ligand. Weaker ligand idre ಏನಾಗ್ತದೆ, stronger ligand idre ಏನಾಗ್ತದೆ. The stronger ligand it can be form low spin complexes and weaker ligand it can be form high spin complexes, high spin or spin free complexes. ನೋಡಿ ಇಲ್ಲಿ F minus ಅಂತ ಹೇಳೋದು it is a weaker ligand. Here also F minus is a weaker ligand. Oxalato C2O4 is an oxalato, it is a stronger ligand, and water it is also weaker ligand. Here in case of the oxalato, okay, is a stronger ligand. Therefore the gap between the two levels, like for example it is an octahedral complex, ಆದ ಕಾರಣ T2G and EG ಲೆವೆಲ್ ಇರ್ತದೆ. ಈ T2G ಮತ್ತೆ EG ಲೆವೆಲ್ ನಡುವೆ ದ ಎನರ್ಜಿ ಗ್ಯಾಪ್ ಜಾಸ್ತಿ ಇರ್ತದೆ. ಜಾಸ್ತಿ ಇದ್ದಾಗ ಏನಾಗ್ತದೆ, ದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಕೆನಾಟ್ ಮೂವ್ ಟು ದಿ ಅಪ್ಪರ್ ಲೆವೆಲ್ ಅನ್ಲೆಸ್ ಇಟ್ ಕ್ಯಾನ್ ಬಿ ಪೇರ್ಡ್. ಫಸ್ಟ್ ಗೆ ಏನಾಗ್ತದೆ, ದ ಪೇರ್ಡ್ ಇನ್ ದ ಗ್ರೌಂಡ್ ಲೆವೆಲ್, ದೆನ್ ಇಟ್ ಕ್ಯಾನ್ ಬಿ ಮೂವ್ ಟು ದಿ ಹೈಯರ್ ಲೆವೆಲ್. Therefore in the complex like CO, C2 C2O4, that is a trioxalato cobalt 3 complex. Here C2O4 tris or oxalato is a stronger ligand. Therefore, it cannot be moved to the higher level. Therefore, cobalt. Central metal ion is a cobalt. Other electronic configuration hegirtade, the argon. Then 3d74s2. ನೋಡಿ ಈ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಅನ್ನು ನಾವು ನೆನಪಿಡ್ಕೊಳ್ಳುವಾಗ ಹೇಗೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಒನ್ ಆಫ್ ದ ಎಲಿಮೆಂಟ್ ಅನ್ನ ನೆನಪಿಡ್ಕೊಳ್ಳೋದು. ಇನ್ನು 3D ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ ಮಾತ್ರ ನಾವು ಸ್ಟಡಿ ಮಾಡೋದು. ಸ್ಕ್ಯಾಂಡಿಯಂ, ಟೈಟಾನಿಯಂ, ವೆನೇಡಿಯಂ, ಕ್ರೋಮಿಯಂ, ಮ್ಯಾಂಗನೀಸ್, ಐರನ್, ಕೋಬಾಲ್ಟ್, ನಿಕ್ಕಲ್, ಕಾಪರ್ ಅಂಡ್ ಜಿಂಕ್. ಇಲ್ಲಿ ನಾನು ಐರನ್ ಅನ್ನ ಫಿಕ್ಸ್ ಮಾಡಿ ಇಟ್ಕೊಳ್ತೀನಿ. ಐರನ್ ಇಸ್ 3d6 4s2. ನೆಕ್ಸ್ಟ್ ಕೋಬಾಲ್ಟ್ ಬಂದಾಗ ನಾನು ಏನ್ ಮಾಡ್ತೀನಿ ಅಂತ ಹೇಳಿದ್ರೆ 3D ಗೆ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ಆಡ್ ಮಾಡ್ತೀನಿ. therefore it like a 3d7 4s2. in this complex the cobalt is in the +3 oxidation state. ಅದರ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಎಷ್ಟಿದೆ? +3 ಇದೆ. do you know that +3 ಬಂದಾಗ ಏನಾಗ್ತದೆ? electron it can be loses. therefore you are getting the configuration like argon, then 3d6 ಅಂತ ಬಂತು. 3d6. as I told earlier, the oxalato is a strong ligand ಆದಾಗ there are two level like a T2G level and EG level ಅಂತ ಬರ್ತದೆ. EG level, T2G level ಅಲ್ಲಿ ಟೋಟಲ್ ಆಗಿ 3 ಆರ್ಬಿಟಲ್ಸ್ ಇರ್ತದೆ, EG ಅಲ್ಲಿ 2 ಆರ್ಬಿಟಲ್ಸ್ ಇರ್ತದೆ. therefore the total electrons ಎಷ್ಟಿತ್ತು? 6 electrons are there in cobalt 3+. ಹಾಗಾಗಿ the first electron can occupy here, the second electron come occupy here, third electron, then fourth electron it can become and the pair it here. therefore you are getting the 3 paired electrons. therefore there is no unpaired electron. therefore it has the magnetic moment mu is equal to square root of 0 into 0 plus 2. okay, hagagi 0 into any number you are getting the 0. therefore the answer is 0. therefore the correct option is option number C. which of the following complex has zero spin only magnetic moment? That is the correct option for that question is the option number C, that is a trioxalato cobalt 3 complex. okay, the next we will move on to the next question. in a Bohr's radius of hydrogen atom in a ground state is 0.6 angstrometer. find out Bohr's radius of third orbit of helium plus ion. ನಮ್ಗೆ ಗೊತ್ತಿದೆ, according to the Bohr's theory it can be find out the whatever the atomic structure, it is for the single electron system. helium plus ಅಂತ ಹೇಳಿದ್ರೆ the helium, the atomic number 2, helium plus ಆದಾಗ ಏನಾಯ್ತು? therefore it can be loses one electron, therefore it contains a single electron. now what is the formula you can be used? ನಮ್ಗೆ ಗೊತ್ತಿದೆ the radius of the nth orbit ಅನ್ನು find out ಮಾಡೋ formula Rn is directly proportional to the n square divided by z, where n ಅಂತ ಹೇಳಿದ್ರೆ which orbit or which level, and z is nothing but the atomic number. here the case is a helium, therefore the atomic number ಅಂತ ಹೇಳೋದು z is 2. then here Rn is proportional to n square by z or Rn. They are given. If Bohr's radius of hydrogen atom in ground state is 0.6 angstrometer, that is nothing but Rn is equal to some A0. The A0 is nothing but 0.6 into n square divided by z. Or the A0 is 0.6 angstrometer. Therefore 0.6 into the level is third orbit, radius of the third orbit, therefore n is equal to 3 square divided by z is 2. therefore you are getting the calculate this one 0.6, here 3 square is 9 divided by 2, here 2, therefore 0.6 into 9, therefore 9 6 what is the answer? 9 6 is 54, but it is 5.4 divided by 2. therefore you are getting the answer is 5.4 divided by 2 is 2.7 angstrometer. therefore the correct answer for this one is option number A, 2.5 angstrom. Okay, the method 0.6 into n square. N square is 3 square divided by z. Z is nothing but the atomic number. 0.6 into 9. 9 6 are 54, but 0.6 into 9, that is, so you can put the 5.4 divided by 2 divided by 2. Therefore, you are getting answer is 2.7 angstrom. Therefore, the correct answer for the question number 2 is 2.7 angstrom. The next question number 3. In which of the molecule dehydrohalogenation forms maximum number of isomer excluding rearrangement? It cannot undergo the rearrangement. Rearrangement aglikilla, excluding the rearrangement. Therefore, in which of the molecule dehydrohalogenation? Do you know that? What is dehydrohalogenation? Dehydrohalogenation anta helidre hydrogen hogbeko, along with the hydrogen, halogen also eliminate. Therefore, that is called a dehydrohalogenation. Therefore, here we will look on the questions and also the option number A, then option number B, option number C, option number D. Nodi, in this case, it can be eliminated. For example, here CH2Br is there. Okay, CH2 group is there. Whenever it can be undergo the eliminate, you are getting the only one product. Only one product. Here in this case, here there is no hydrogen, here there is no hydrogen, no H, no hydrogen. Only the elimination product can be obtained only here. Only here. Here also you are getting the only one product. Okay. Then whenever you can be come to the here, the Br, it can be eliminated the H from here or here. Okay. Here one product. And also here you can get the another product. Therefore, you are getting the total product is 2. Total number of the isomers, maximum number of the isomers with the after elimination, you are getting the 2. But whenever go for this option number A, the first one is it can be eliminated from here. There is a formation of the double bond here. CH2 is there. It becomes CH2 double bond. Then elimination of the Br here. Then single bond CH2, CH2, CH3. The one of the product is like this. The product is CH2 double bond CH, CH2, then CH2, CH3. The one of the product is this one. Then another case, it can be elimination of the hydrogen from this carbon atom. The whenever the hydrogen can be eliminated from here, here there are 2 H's there. Okay, eliminated from this carbon atom. Therefore, you are getting there are 2 isomers. The one is cis isomer, another one is a trans isomer. Cis and trans isomer. Therefore, here whenever the hydrogen can be eliminated from this carbon atom, it can be formed the 2 isomers. The one of the product is this one. The another one is cis product. Cis alkene, there is a formation of the cis alkene. The another one is it can be formed the trans alkene. Okay, trans alkene. Therefore, whenever you can be move on to the option number A, it can be formed. There are 3 alkenes. Okay, the 1, 2, 3. Therefore, the maximum number of the isomer it can be formed in case of the option number A. The one is this one, the another one is cis, another one is a trans product. Therefore, the correct answer is option number A. The next question number 4, assertion. First law of thermodynamics has equation delta U is equal to Q plus W. That is on the system. If the system is on, the work done is positive. Therefore, delta U is equal to Q plus W. By the system, delta U is equal to Q minus W. The reason, first law of thermodynamics is based on the law of conservation of the energy. That is, whatever the energy, neither be created nor be destroyed. Therefore, first law of thermodynamics is delta U is equal to Q plus W. That is correct. The second, the first law of thermodynamics, there is a reason is the first law of thermodynamics is based on the law of conservation of the energy. That is also correct. Therefore, here A is correct, R is correct, and R is the correct explanation of the A. Correct explanation of the A. Do you know that? Whatever the change in the internal energy, that is the total energy in the system, is equal to the heat content of the system plus the work done. Work done. Therefore, both are correct. Therefore, the option number A is the correct. A is correct and R is correct, and R is the correct explanation of the A. We will move on to the next question. Okay, consider the following sequence of the reactions. Okay, here some carbonyl compound is there. Initially, you can be react with zinc with mercury and HCl. Zinc, mercury, HCl. That is, do you know that it is nothing but Clemmensen reduction? Clemmensen reduction. Clemmensen reduction. Okay. After that, it can be react with the lithium aluminum hydride, and followed by acid hydrolysis. Acid hydrolysis. What is the product obtained? The first step, whenever it can be react with the Clemmensen reduction. Clemmensen reduction. Do you know that? Whenever you can use the Clemmensen reduction, it can be converted the carbonyl grouped into the hydrocarbon. That is C double bond O group idre adu ಏನನ್ನಾಗಿ convert ಮಾಡ್ತದೆ? It can be converted to the CH2. CH2 ಆಗಿ convert ಮಾಡ್ತದೆ. CH2. It can be converted to the CH2. Okay, not only in the Clemmensen reduction, or you can take Wolff-Kishner reduction ಅನ್ನು ಮಾಡಬಹುದು. ಆವಾಗ you are getting the corresponding hydrocarbon, the carbonyl compound. The first step ಅಲ್ಲಿ ಅದು ಎಲ್ಲಿ reduction ಮಾಡ್ತದೆ? It can be reduction on the whatever the carbonyl group which can be attached to the benzene ring. Adana reduction ಮಾಡ್ತದೆ. The first step, the Clemmensen reduction, you are getting the product is like this. The benzene ring, C double bond O, then CH2, then C double bond O becomes okay, it becomes a CH2. Okay, it becomes CH2. Then C double bond O here. Then NR2. NR2. Okay, the first it can be reduce this carbonyl group into the CH2 group. CH2 group. Then followed by it can be react with lithium aluminum hydride. The lithium aluminum hydride is a strong reducing agent. Therefore, it can be reduced this carbonyl group also. Therefore, you are getting the product is the benzene ring with the CH2, 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 then NR2, NR2, NR2. Therefore, the correct answer is you are getting the correct answer is this one. Option number D. Option number D. Okay, option number D is the correct answer. The first it can be reduced this one, then it can be reduced the carbonyl group also. Therefore, you are getting the product is option number D is the correct answer. The next, the equilibrium constant Kc for the reaction nitrogen plus O2 to give the 2NO. 2NO. It is both forward and backward because of the equilibrium reaction. Okay, then at the temperature T is, they are given the equilibrium constant, that is a 4 into 10 to the power of minus 4. The value of Kc for the reaction NO get converted to the half N2 plus half O2 at the same temperature is. First you can observe these two equations. ಈ ಎರಡು equations ಅನ್ನು ನಾವು ಒಮ್ಮೆ ನೋಡ್ಕೊಳ್ಳೋಣ. Okay, ಏನ್ changes ಇದೆ? The exact reverse of this equation. ಇದರ reverse ಇದೆ ಈ equation. Plus here the 1 mole ಇದೆ, 1 mole of the nitrogen ಇದೆ. Here half mole of the nitrogen, half. ಅಂದ್ರೆ exact half of that. Then in this case they are given the equilibrium constant for the first reaction. ಅವರು ಕೊಟ್ಟಿದ್ರು ಎಷ್ಟು? The Kc for the first reaction is 4 into 10 to the power of minus 4. You have to find out the equilibrium constant for the second reaction. What is the difference between these two reactions? It is a exactly opposite. This reaction is exactly opposite. And also the first case, you are taken the 1 mole of the nitrogen and 1 mole of the oxygen. You are getting 2 mole of nitrogen monoxide. Second case ali adu reverse agide. Along with that, there is a half of that. Okay, that is a 1 mole of the nitrogen monoxide. It can be undergo the decompose to give the half mole of the nitrogen and half mole of the oxygen. Here it is exactly opposite. The one is like a forward or backward type of the reaction. Here, do you know that for forward reaction Kc idadre, backward reaction ige ನಾವು Kc ಅನ್ನು find out ಮಾಡ್ಲಿಕ್ಕೆ ಹೋದ್ರೆ, for example, it is for the backward, quite opposite. It is 1 by that of the forward reaction. Okay, forward reaction, or for example, here the back forward, then you are taking the backward reaction, 1 by that of the backward reaction, like that. Therefore, it is the relationship. Therefore, in this case, you can be find out this value. Therefore, the rate constant or equilibrium, not rate constant, equilibrium constant for the second reaction is equal to 1 by the equilibrium constant of the first reaction. Equilibrium constant of the first reaction, I can write this one is a Kc dash, another one is the first one is a Kc, and you can make it the half of that, exactly half to the power of 1 by 2. Kc dash is equal to 1 by Kc whole to the power of 1 by 2. 1 by 2 ಮಾಡಿದಾಗ, therefore the equilibrium constant for the second reaction is equal to 1 by 4 into 10 to the power of minus 4 whole to the power of 1 by 2. 1 by 2. Then do you know that here it becomes like 1 by whole to the power of 2. You can take the square root for this one. You are getting the answer is 1 by 2 into 10 to the power of minus 2. 1 by 2 into 10 to the power of minus 2. 1 by 2 into 10 to the power of minus 2. That is nothing but, okay, here 2, 1 by 2, 10 to the power of minus 2 ide. 10 to the power of minus 2 denominator ಅಲ್ಲಿ ಇದೆ, ಅದನ್ನ ನ್ಯೂಮರೇಟರ್ ಗೆ ತಕೊಂಡು ಹೋದ್ರೆ it becomes 10 to the power of plus 2 ಆಯ್ತು. Therefore 10 to the power of 2 whole dividing by 2 ಅಂತ ಇದೆ. Therefore 100, 10 to the power of 2 is 100, divided by 2 is nothing but the 50. Therefore the answer is 50. Therefore the correct answer is option number D, that is 50.0. 50.0. Okay, that is about the question number 6. The next, molarity of carbon dioxide in soft drinks is 0.01 molar. Molarity anna kottidru, that is molarity is nothing but the concentration. They are given 0.01 molar. Okay, it is in terms of the molarity. The volume of the soft drinks is 300 ml. Volume anna kottidru, that is 300 ml. You have to calculate mass of the carbon dioxide in soft drinks. ಆಯ್ತಾ, ನೀವು weight ಅನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. weight or mass or weight of the carbon dioxide ಅನ್ನು ನೀವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. You can be calculate. Do you know that the molar mass of the carbon dioxide ನಮಗೆ ಗೊತ್ತಿದೆ? There is a more familiar for us. There is a 44 gram per mole. 44 CO2 carbon 1 ಇದೆ, 1 into 12 plus oxygen 2 ಇದೆ, 2 into 16, 32 plus 12 is 44 ಅಂತ ಬಂತು. Okay, do you know the definition of the molarity? Molarity ಅಂದ್ರೆ ನಮಗೆ ಗೊತ್ತಿದೆ. What is molarity? Molarity is equal to the number of moles of the solute divided by volume of the solution in liters. Volume of the solution in liters. There is a volume of the solution is the volume in of the solution in liters. ಆಯ್ತಾ, that is about the molarity. ಈಗ ನಾವು moles ಅನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡುವ. First you have to calculate the moles. Then moles is multiply with the molar mass, you are getting the mass. Okay, do you know that the mole anta helidre enu, the mass of the substance divided by their molar mass or the atomic mass anna takondre, that is about the moles. First ige moles, the number of moles of the carbon dioxide is equal to molarity into the volume in liters. Therefore the molarity is 0.01 into volume is 300 ml ante ide. You can be convert into the liter, you can divide it by 1000, you are getting the answer is 0.3 liter, 0.3 liter, therefore 0.3, 0.3, okay, 0.3, therefore you can multiply, therefore you are getting the answer is 0.003, 0.003, okay, 0.003 moles anta bantu. Then you have to calculate the mass anna nanu calculate ಮಾಡಬೇಕು. Mass, I can be calculate the mass of the carbon dioxide, small letter m of the carbon dioxide is equal to mass. Here moles is equal to mass divided by the molar mass. Mass anta ಹೇಳಿದ್ರೆ ಏನಾಯ್ತು, the whatever the moles into their molar mass. Therefore moles is 0.003 into 44, into 44, you are getting the answer, you are getting the answer. What is the answer? 0.003 into 44, into 44, into 44, you are getting the answer is 0.01, 0.00, therefore 0.132 gram, 0.132 gram, you are getting the answer is 0.132 gram, 0.132 gram, 0.132 gram, therefore the correct answer is option number A. Okay, clear no? First ಏನು ಮೊಲಾರಿಟಿ ಅನ್ನ ಕೊಟ್ಟಿದ್ರು, ವಾಲ್ಯೂಮ್ ಅನ್ನ ಲೀಟರ್ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು, you have to calculate the mass ಅನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. molar mass ಅನ್ನ there we know that carbon dioxide and molar mass 44. first you have to calculate the ಏನು moles ಅನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ, you are getting the 0.003 moles ಬರ್ತದೆ. Then in terms of the moles you have to calculate the mass of the carbon dioxide, therefore 0.003 into 44, you are getting the correct answer is 0.132 gram, option number A. The next, the most suitable method for separation of the 1:1 mixture of the ortho and para nitrophenol. ನೋಡಿ, ಈ ಆರ್ಥೋ ನೈಟ್ರೋ ಮತ್ತೆ ಪ್ಯಾರಾನೈಟ್ರೋಫಿನಾಲ್ ಅಂತ ಹೇಳುದು ಇಟ್ ಇಸ್ ಮೋರ್ ಫೆಮಿಲಿಯರ್. ನಾವು ಫಸ್ಟ್ ಇಯರ್ ಅಲ್ಲಿ ಈ ಡಿಸ್ಟಿಲೇಷನ್ ಬಗ್ಗೆ ಸ್ಟಡಿ ಮಾಡಿದಾಗ ನಾವು ಅಲ್ಲಿ ನೋಡಿದ್ದು. ಓಕೆ, ಹಿಯರ್ ಇನ್ ಕೇಸ್ ಆಫ್ ದಿ orthonitrophenol and paranitrophenol, do you know that the structure of the orthonitro and paranitrophenol, orthonitrophenol and paranitrophenol, here in case of the orthonitrophenol alli there is a formation of the intramolecular hydrogen bonding. ಇಲ್ಲಿ ಇದರದ್ದು ಒಂದು ಪ್ರಾಪರ್ಟಿ ಇದೆ, ಏನಂತ ಹೇಳಿದ್ರೆ it can be forms intramolecular hydrogen bonding. Do you know that hydrogen bond ಅಲ್ಲಿ ಎರಡಿದೆ, the one is intermolecular, another one is intramolecular. Here in this case of the orthonitrophenol it can be form intramolecular hydrogen bonding. Do you know that what is hydrogen bond? Hydrogen bond anta helidre the hydrogen it can be bonded with more electronegative element like oxygen agirbodu, nitrogen agirbodu, or in case of the fluorine also. Okay, that is called say intramolecular hydrogen bonding. Okay, like that, therefore it can be form the hydrogen bond here. Okay, it can be form the hydrogen bond here. Okay, hydrogen bond here, therefore it is known as the intramolecular hydrogen bonding. Whenever the molecule having the intramolecular hydrogen bonding, ಈ ತರ ಹೈಡ್ರೋಜನ್ ಬಾಂಡಿಂಗ್ ಇದ್ದಾಗ therefore ಏನಾಗ್ತದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಅದರ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಜಾಸ್ತಿ ಆಗ್ತದೆ, ಬಿಕಾಸ್ ಆಫ್ ದಿ ಸಮ್ ಎಕ್ಸ್ಟ್ರಾ ಬಾಂಡಿಂಗ್ ಅಥವಾ some extra force of attraction ಇರ್ತದೆ, force of attraction, therefore it can be boiled at higher temperature compared to other compound, therefore in case of the orthonitrophenol it has a more boiling point compared to that of the paranitrophenol. ಹಾಗಾಗಿ ಏನಾಗ್ತದೆ ಅಂತ ಹೇಳಿದ್ರೆ therefore ಅದರ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಡಿಫರೆನ್ಸ್ ಇರ್ತದೆ. ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಡಿಫರೆನ್ಸ್ ಇದ್ರೆ we have to go for the ಏನೋ ಟೆಕ್ನಿಕ್ ಅನ್ನು ಯೂಸ್ ಮಾಡ್ತೀವಿ, ಡಿಸ್ಟಿಲೇಷನ್. ಈ ಡಿಸ್ಟಿಲೇಷನ್ ಅಲ್ಲಿ ಬೇರೆ ಬೇರೆ ಇದೆ, ಒಂದು ಸಿಂಪಲ್ ಡಿಸ್ಟಿಲೇಷನ್, ಸ್ಟೀಮ್ ಡಿಸ್ಟಿಲೇಷನ್ ಆರ್ ಫ್ರಾಕ್ಷನಲ್ ಡಿಸ್ಟಿಲೇಷನ್. Okay, therefore you can be go for the distillation. There is a large difference in their boiling point. Boiling point alli difference iddaga you can go for the distillation. The correct answer is distillation. Next ಉಳಿದದ್ದು ಇದೆ crystallization ಅಂತ ಇದೆ. The what is crystallization? Do you know that? It depends upon the solubility. The solubilities. It depends upon the principle of the solubilities. ಇದು ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಹೇಗೆ, ಇದು ಸಾಲಿಬಿಲಿಟೀಸ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರ್ತದೆ. ಸಬ್ಲಿಮೇಷನ್ ಅಂತ ಹೇಳಿದ್ರೆ ಡು ಯು ನೋ ದಟ್ ದ ಎನಿ ಕಾಂಪೌಂಡ್ ಇನ್ ದ ಸಾಲಿಡ್ ಅಲ್ಲಿ ಇದ್ದದ್ದು ಡೈರೆಕ್ಟ್ ಆಗಿ ಗೇಸಿಯಸ್ ಸ್ಟೇಟಿಗೆ ಕನ್ವರ್ಟ್ ಆಗಬೇಕು ವಿದೌಟ್ ಇಂಟರ್ ಕನ್ವರ್ಷನ್ ಆಫ್ ದಿ ಲಿಕ್ವಿಡ್ ಸ್ಟೇಟ್, ದಟ್ ಇಸ್ ಸಬ್ಲಿಮೇಷನ್. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ iodine or ammonium chloride can be purified by the sublimation. Then chromatography ಅಲ್ಲಿ ವೇರಿಯಸ್ ಟೆಕ್ನಿಕ್ ಅನ್ನು ನೀವು ನೋಡಿದ್ರಿ. ಇನ್ ಕೇಸ್ ಆಫ್ ದ ಆರ್ಗ್ಯಾನಿಕ್ ಕಾಂಪೌಂಡ್ can be purified by the chromatography like a TLC, thin layer chromatography, or paper chromatography, or column chromatography, like that. Okay, these are other techniques. Therefore, here the most suitable method for the separation of the 1:1 mixture of the ortho and para-nitrophenol is distillation. The correct answer is distillation. The next, following compounds are given. Okay, you have to look at the compounds. Compare pKa values. pKa values. You have to compare the pKa values. Do you know that what is pKa? pKa anta helidre negative log of base 10 Ka, that is dissociation constant Ka. Here how it can be depend on the acidic or basic character of the any compound. Nodi, if the Ka value increases, their dissociation constant increase adre ಅದರ acidic character increase ಆಗ್ತದೆ. Okay, we will discuss only about the acidic. ಆಯ್ತಾ, ಬೇಸಿಕ್ ಬಂದಾಗ ರಿವರ್ಸ್ ಆಗ್ತದೆ. acidic also increase, acidic character also increase. ಅದೇ in terms of the pKa value ಬಂದಾಗ pKa value ಕಡಿಮೆ ಆದ್ರೆ it can be decrease. Therefore the acidic character ಅಂತ ಹೇಳೋದು increase ಆಗ್ತದೆ. acidic character is increase. Now here they are compare the pKa values. ಅದರ ಅರ್ಥ ಏನು, pKa ವ್ಯಾಲ್ಯೂ ಯಾವುದಕ್ಕೆ ಜಾಸ್ತಿ ಇದೆ ಅದು ಏನಾಗಿರ್ತದೆ, therefore less acidic ಆಗಿರ್ತದೆ. pKa decrease the more acidic, pKa increase it is less acidic ಆಗ್ತದೆ. pKa increase it becomes less acidic ಆಗ್ತದೆ. less acidic. Therefore ಯಾವುದಕ್ಕೆ pKa ಜಾಸ್ತಿ ಇದೆ that one is less acidic. Now we will compare. ಆಯ್ತಾ, ನೋಡುವ. the OH is common. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಬೆನ್ಸಿನ್ಗೆ OH ಅಟ್ಯಾಚ್ ಆಗಿದ್ದು ಕಾಮನ್ ಆಗಿದೆ. ಅದು ಬಿಟ್ರೆ ಬೇರೆ ಏನಿದೆ, ಇಲ್ಲಿ ನೈಟ್ರೋ ಗ್ರೂಪ್ ಇದೆ, ಇಲ್ಲಿ ಮಿಥೈಲ್ ಗ್ರೂಪ್ ಇದೆ, ಇಲ್ಲಿ ಓನ್ಲಿ ಒನ್ ನೈಟ್ರೋ ಗ್ರೂಪ್ ಇಸ್ ದೇರ್, ಹಿಯರ್ ಒನ್ Cl ಗ್ರೂಪ್ ಇಸ್ ದೇರ್. ಡೂ ಯು ನೋ ದಟ್ ದ ನೈಟ್ರೋ ಗ್ರೂಪ್ ಅಂತ ಹೇಳುದು ಎಲೆಕ್ಟ್ರಾನ್ ವಿತ್ ಡ್ರಾಯಿಂಗ್ ಗ್ರೂಪ್. ಆಯ್ತಾ, ಎಲೆಕ್ಟ್ರಾನ್ ವಿತ್ ಡ್ರಾಯಿಂಗ್ ಗ್ರೂಪ್. whenever the nitro group it can be present in the benzene ring, ಅದರ acidic character ಅನ್ನ ಏನ್ ಮಾಡ್ತದೆ ಅಂತ ಹೇಳಿದ್ರೆ it can be increases the acidic character. ಅದೇ electron donating group like CH3 group ಇದ್ರೆ ಅದು ಏನ್ ಮಾಡ್ತದೆ, their acidic character ಅನ್ನ decrease ಮಾಡ್ತದೆ. acidic character ಅನ್ನ it can be decreases. Therefore the compare the pK values. Therefore the highest pK values ಇರುವುದು ಯಾವುದಕ್ಕಂತ ಹೇಳಿದ್ರೆ therefore it is a least acidic ಆಗಿರಬೇಕು, least acidic. Therefore the option number 3 ಇದಕ್ಕೆ highest ಇದೆ. Okay, it is a maximum. Therefore option number 3 ಬಂದದ್ದು ಎಲ್ಲಿದೆ, pK values, this one. Okay, now we will compare. The option number 3 is highest, then option number 2, okay, then option number 4, then option number 1. Therefore the correct answer, therefore it has the highest pK value, therefore option number 3, then option number 2, the next option number 4, then option number 1. Therefore the correct answer, the highest pK values for the option number 3, the least pK values for the option number 1. Okay, option number 1. It is clear, no? That pKa is equal to negative log of base 10 Ka increase, acidic character increases, but pK value decrease, the acidic character increase, then pK value increase, the acidic character decrease. Like that. For example, you have to compare with the basic character, even you compare ಮಾಡಬಹುದು, acidic character and the basic character. ಇನ್ನು ಜನರಲ್ ಆಗಿ ನಾವು ಹೇಳೋದಾದ್ರೆ ಒಂದು acidic character ಅಂತ ಹೇಳಿದ್ರೆ the molecule ಅಲ್ಲಿ less electron density ಇರಬೇಕು. The basic character ಅಂತ ಹೇಳಿದ್ರೆ it has a more electron density ಇದ್ರೆ therefore it is a more basic. Okay, the next, the correct order of bond strength of the water H2S, H2SC and H2TE. There is a ಆಕ್ಸಿಜನ್, ಸಲ್ಫರ್, ಸೆಲೇನಿಯಂ ಅಂಡ್ ಟೆಲ್ಲೂರಿಯಂ ಆಯ್ತಾ. ದ ಕರೆಕ್ಟ್ ಆರ್ಡರ್ ಆಫ್ ಬಾಂಡ್ ಸ್ಟ್ರೆಂತ್, ಅದರ ಬಾಂಡ್ ಸ್ಟ್ರೆಂತ್ ಹೇಗಿರ್ತದೆ ಅಂತ. ಓಕೆ, here the option is water, H2S, H2SC, H2TE. okay, I can put this question in the chemical bonding and molecular structure. okay, chemical bonding and molecular structure, the strength of the bond. okay, for example illi nodi oxygen ide, sulfur ide, selenium ide, tellurium ide, namage order gottide. These are all belongs to the group number, is to group number 16, oxygen family, 17 halogen family. Therefore group number 16 ಅಲ್ಲಿ ಬರ್ತದೆ oxygen, then sulfur, selenium, then tellurium. The correct order of the bond strength, okay, bond strength, H2O, H2S, H2SC and H2TE. Whenever you can be moved down the group, okay, down the group, you have to study the periodic table. ನೋಡಿ, ನಾವು ಪಿ ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ ಅನ್ನ ಸ್ಟಡಿ ಮಾಡಿದ್ರು, ಕ್ಲಾಸಿಫಿಕೇಶನ್ ಆಫ್ ದಿ ಎಲಿಮೆಂಟ್ ಅಂಡ್ ಇಟ್ಸ್ ಪಿರಿಯಾಡಿಕ್ ಪ್ರಾಪರ್ಟೀಸ್ ಅಲ್ಲಿ ನಾವು ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ. ಓಕೆ, ದ ವಾಟ್ ಎವರ್ ದ ಎಸ್ ಬ್ಲಾಕ್, ಪಿ ಬ್ಲಾಕ್, ಡಿ ಬ್ಲಾಕ್ ಅಂಡ್ ಎಫ್ ಬ್ಲಾಕ್. ಡಿ ಅಂಡ್ ಎಫ್ ಬ್ಲಾಕ್ ಅನ್ನ ನಾವು ಕಂಪ್ಲೀಟ್ ಆಗಿ ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ, ಬಟ್ ಎಸ್ ಅಂಡ್ ಪಿ ಆರ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ ದ ಕ್ಲಾಸಿಫಿಕೇಶನ್ ಆಫ್ ದಿ ಎಲಿಮೆಂಟ್ ಅಂಡ್ ಇಟ್ಸ್ ಪಿರಿಯಾಡಿಕ್ ಪ್ರಾಪರ್ಟಿ. ವೆನ್ ಎವರ್ ಯು ಕ್ಯಾನ್ ಬಿ ಮೂವ್ ಡೌನ್ ದ ಗ್ರೂಪ್, ಯಾವಾಗ ನೀವು ಮೂವ್ ಡೌನ್ ದ ಗ್ರೂಪ್ ಆಗ್ತೀರಿ ಆವಾಗ their atomic size is increase. atomic size ಏನಾಗ್ತದೆ? increase ಆಗ್ತದೆ. atomic size increases. atomic size increases as we move along the period. For example, you can move along the period, the atomic size ಅಂತ ಹೇಳಿದ್ರೆ decrease ಆಗ್ತದೆ. Whenever you can move down the group, the atomic size increases. ಓಕೆ, ಯಾವುದು ಆಕ್ಸಿಜನ್, ಸಲ್ಫರ್, ಸೆಲೇನಿಯಂ ಅಟೋಮಿಕ್ ಸೈಜ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತದೆ. ಇಟ್ ಕ್ಯಾನ್ ಬಿ ಬಾಂಡಿಂಗ್ ವಿತ್ ಹೈಡ್ರೋಜನ್. ಹಿಯರ್ ಇಟ್ ಇಸ್ ದ ಸಿಂಗಲ್ ಸೇಮ್ ಎಲಿಮೆಂಟ್, ದಟ್ ಇಸ್ ಹೈಡ್ರೋಜನ್ ಇಟ್ ಸೆಲ್ಫ್. ನೋಡಿ, ಅವು ಬಾಂಡ್ ಅಂತ ಹೇಳುದು ಏನಾಗ್ತದೆ ಅಂತ ಹೇಳಿದ್ರೆ ವೀಕ್ ಆಗ್ತಾ ಹೋಗ್ತದೆ. ವೆನ್ ಎವರ್ ದ ಅಟೋಮಿಕ್ ಸೈಜ್ ಆಫ್ ದ ಎಲಿಮೆಂಟ್ ಇನ್ಕ್ರೀಸಸ್, ದ ಸೇಮ್ ಎಲಿಮೆಂಟ್ ಒಟ್ಟಿಗೆ ಬಾಂಡಿಂಗ್ ಆದಾಗ ಏನಾಗ್ತದೆ, ಆ ಬಾಂಡ್ ಅಂತ ಹೇಳುದು ವೀಕ್ ಆಗ್ತಾ ಹೋಗ್ತದೆ. ಓಕೆ, ಬಿಕಾಸ್ ನಿಮ್ಗೆ ಗೊತ್ತಿದೆ ಒಂದು ಬಾಂಡ್ ಅಂತ ಹೇಳಿದ್ರೆ ಏನು. It is a, for example, hydrogen, in case of the covalent bond adre, it is a overlapping the orbital along with the nucleus irtade, therefore it can be overlapping. That size is bigger, therefore the bond anta heludu enagtade, weak aagta hogtade. Whenever you can be moved down the group, the bond is weaker. The correct order of the bond strength of the water, H2S, H2TE is H2TE, that is a tellurium. ಅದರ ಬಾಂಡ್ ಅಂತ ಹೇಳುದು ವೀಕ್ ಆಗಿರ್ತದೆ, ವಾಟರಿನ ಬಾಂಡ್ ಅಂತ ಹೇಳುದು ಸ್ಟ್ರಾಂಗ್. therefore the correct answer is option number A, water, H2S, H2SC and H2TE. The next, the compound that gives more stable carbocation on dehydration. Do you know that what is the meaning of the dehydration? Dehydration means the removal of the water anta, removal of the water. ಈ 4 ಕಾಂಪೌಂಡ್ ಅಲ್ಲಿ ಯಾವುದರಲ್ಲಿ ಡಿಹೈಡ್ರೇಷನ್ ಆದಾಗ ಇಟ್ ಕ್ಯಾನ್ ಬಿ ಗಿವ್ ದ ಮೋರ್ ಸ್ಟೇಬಲ್ ಕಾರ್ಬೋಕ್ಯಾಟಯಾನ್. ಯು ಕ್ಯಾನ್ ಬಿ ಸ್ಟಡಿಡ್ ದಿಸ್ ಒನ್ ಇನ್ ದ ಫಸ್ಟ್ ಇಯರ್ ಅಲ್ಲಿ ನಾವು ಸ್ಟಡಿ ಮಾಡ್ತು ರಿಯಾಕ್ಷನ್ ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಅಂತ. ಈ ರಿಯಾಕ್ಷನ್ ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಅಲ್ಲಿ ಹೇಗೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ದ ಒನ್ ಇಸ್ ಕಾರ್ಬೋಕ್ಯಾಟಯಾನ್ ಇಸ್ ದೇರ್, ಕಾರ್ಬೋ ಆನಯಾನ್ ಇಸ್ ದೇರ್, another one is ಫ್ರೀ ರಾಡಿಕಲ್ ಇದೆ. In case of the carbocation anta bandaga, alli tertiary carbocation is a more stable, then secondary, then primary. The next methyl carbocation anta you consider ಮಾಡಬಹುದು. Therefore in case of the carbocation, carbo anions anta bandaga alli yavudu irtade, it is a reverse, primary, then secondary, then tertiary. Ade free radical anta bandaga, for example any free radical or carbon free radical, ಅಲ್ಲಿ ಮತ್ತೊಂದು ಆರ್ಡರ್ ಇಸ್ ಸೇಮ್, ಟರ್ಷರಿ, ದೆನ್ ಸೆಕೆಂಡರಿ, ದೆನ್ ಪ್ರೈಮರಿ ಆಗಿರ್ತದೆ. ಓಕೆ, therefore in carbocation the order is like this: tertiary carbocation is more stable, then secondary, then primary. ನಾವು ಈಗ ನೋಡುವ 2-methyl prophenol ಇದೆ. 2-methyl prophenol, you can write the structure. ನೋಡಿ, ಒಂದು ಸ್ಟ್ರಕ್ಚರ್ ಅನ್ನ ಬರೆಯುವುದು ಹೇಗೆ, ಆರ್ಗ್ಯಾನಿಕ್ ಕಾಂಪೌಂಡಿನ ಸ್ಟ್ರಕ್ಚರ್ 2-methyl prophenol ಅಂತ ಇದೆ. ಹೇಗೆ ಬರೀಬಹುದು? 2-methyl prophenol. ಓಕೆ, prophenol. ಓಕೆ, ಹಿಯರ್ ಪ್ರೋಫೇನ್ ಅಂತ ಹೇಳುದು ಅದರ ರೂಟ್ ವರ್ಡ್. ಪ್ರೋಫೇನ್ ಅಂದ್ರೆ ಎಷ್ಟು ಕಾರ್ಬನ್ ಬೇಕು? 3 ಕಾರ್ಬನ್ ಬೇಕು. Propanol, therefore the first carbon ಗೆ OH ಇದೆ. For example, this one is the first carbon, OH, second, third. ಎರಡನೇ ಕಾರ್ಬನ್ ಗೆ ಮಿಥೈಲ್ ಗ್ರೂಪ್ ಇದೆ. Okay, like this. Therefore, the structure of the 2-methyl propanol is like this. That is CH3, CH, CH3, CH2, OH, like that. Okay. Then another one is tertiary butyl alcohol ide. Then N-butanol ide. N-butanol anta helidre linear compound. It contains 4 carbon atom. It is a linear. Then secondary butanol anta ide. Secondary butanol andre secondary carbon ಗೆ OH attach agide anta. Secondary carbon ಅದಕ್ಕೆ OH attach agide. Therefore, it is called as a secondary butanol. Secondary butanol. Another one say the option number B anta helodu eno tertiary butyl alcohol. Do you know that? In SN1 reaction ಅಲ್ಲಿ ನೀವು ಸ್ಟಡಿ ಮಾಡಿದ್ರೆ tertiary butyl alcohol ಹೇಗಿರ್ತದೆ? CCH3, CH3, CH3, OH ಈ ತರ ಇರ್ತದೆ tertiary butyl alcohol. Tertiary butyl alcohol. ನೋಡಿ, in case of the tertiary butyl alcohol, you can add the H plus. There is a OH to plus ಆಗಿ formation ಆಗ್ತದೆ. It can be remove the water. You are getting the carbocation is a tertiary carbocation. Nodi, C plus with CH3, CH3, CH3. CH3, CH3. Therefore, this carbocation is the more stable because the tertiary carbocation is a more stable. Therefore, the correct answer for this one is option number B, tertiary butyl alcohol. It can be formed the tertiary butyl alcohol. The next. The pOH of a solution is 5.0. The concentration of the H plus of the solution is concentration of the H plus ಅನ್ನು ನೀವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. Okay, how to solve this one? ಇಲ್ಲಿ ನಾವು ಇದನ್ನು ಸಾಲ್ವ್ ಮಾಡಬೇಕಾದ್ರೆ ಕೆಲವೊಂದು ಕಾನ್ಸೆಪ್ಟ್ ನಮಗೆ ಗೊತ್ತಿರಬೇಕಾಗ್ತದೆ. ಒಂದು ವಾಟ್ ಈಸ್ pH ಅಂದ್ರೆ ಏನಂತ ಗೊತ್ತಿರಬೇಕು. pH is equal to negative log of base 10 concentration of the H plus ion. Okay, H plus ion. Then pOH anta helidre negative log of base 10 concentration of the OH minus ion. And also the at 25 degree centigrade. Nodi illi temperature anna mention madlilla. Therefore, you have to consider that it is a 25 degree centigrade. The concentration of the H plus ion ಮತ್ತೆ concentration of the OH minus ion anta helodu at 25 degree centigrade alli adara concentration anta helodu 10 to the power of minus 7 mole per decimeter cube. And also we know that the ionic product of the water anta bartade, that is Kw. There is a concentration of the H into concentration of the OH minus ion is equal to 10 to the power of minus 14. 10 to the power of minus 14. ಆಯ್ತಾ? ಈಗ pH ಅಂತ ನಾ ಆವಾಗ ಹೇಳಿದೆ. Therefore, the pOH ಅಂತ ಹೇಳಿದ್ರೇನು? Therefore, pOH, I will write it here. pOH, okay, we required pOH is equal to negative log of base 10 concentration of the OH minus ion. OH minus ion. ಅವ್ರು ಏನ್ ಕೊಟ್ಟಿದ್ರು? pOH ಅನ್ನ ಕೊಟ್ಟಿದ್ರು. pOH is 5. There is 5.0, that is 5 minus log of base 10 concentration of OH minus ion. OH minus ion. Therefore, the concentration of the OH minus ion anta helidre, you can take this minus to the, you can come to the here. Therefore, minus 5. It is log of base 10 OH minus ion. Now ನಿಜವಾಗಿ ಮೈನಸ್ ಅನ್ನು ಈಚೆ ತರಲಿಕ್ಕೆ ಆಗುದಿಲ್ಲ. You have to multiply both sides with -1. ಆವಾಗ ಇದು become -5 ಆಯ್ತು, it become plus. Then OH minus ion concentration ಬೇಕು. That is log of base 10 ಇದೆ. Whenever it can be come to the here, therefore it becomes a 10 to the power of minus 5. Therefore, concentration of the OH minus ion is equal to 10 to the power of minus 5. 10 to the power of minus 5. Okay. Concentration of the OH minus ion ನಮಗೆ ಸಿಕ್ತು. Then concentration of the OH minus ion ಇಲ್ಲಿ ಬೇಕು. Is concentration of the OH minus ion into concentration of the H plus ion ಅಂತ ಹೇಳಿದ್ರೆ 10 to the power of minus 14. Therefore, concentration of the H plus ion is equal to 10 to the power of minus 14 divided by concentration of the OH minus ion, that is 10 to the power of minus 5. Therefore, you are getting the answer is, it goes to the up, therefore it becomes plus 10 to the power of minus 14 plus 5 ಅಂತ ಆಗ್ತದೆ. Do you know that 10 to the power of a divided by 10 to the power of b ಅಂತ ಇದ್ರೆ 10 to the power of a minus b like that, minus 14 plus 5. Therefore, you are getting the answer is 10 to the power of minus 9. 10 to the power of minus 9. Therefore, the correct answer is option number D. Option number D. The next. The basic strength of oxides of vanadium in V2O3, V2O5 and V2O4 are follows in the order. ನೋಡಿ ಈ ಕ್ವಶನ್ ಅನ್ನು ನಾವು ಸಾಲ್ವ್ ಮಾಡುವಾಗ ನೋಡಿ ಆಕ್ಸಿಜನ್ ಇಸ್ ಕಾಮನ್ ಅಂಡ್ ಆಲ್ಸೋ ವೆನೇಡಿಯಂ ಇಸ್ ಕಾಮನ್. ಯಾವಾಗ ಅಂದ್ರೆ ಒಂದು ಎಲಿಮೆಂಟಿನ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಜಾಸ್ತಿ ಆದ್ರೆ ಅದರ ಎಸಿಡಿಕ್ ಸ್ಟ್ರೆಂತ್ ಜಾಸ್ತಿ ಆಗ್ತದ ಅಥವಾ ಕಡಿಮೆ ಆಗ್ತದ, ಆ ತರ ಕಾನ್ಸೆಪ್ಟ್ ಗೊತ್ತಿದ್ರೆ ಯು ಕ್ಯಾನ್ ಟೆಲ್ ದ ಆನ್ಸರ್. ನೋಡಿ, ವೆನ್ಎವರ್ ದ ಮೆಟಲ್ their oxidation number increases, their acidic character also increases. Oxidation number of the metal increases, their acidic character also increases. ನೋಡಿ, here vanadium in oxidation state ಯಾವುದರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರ್ತದೆ? ಆಕ್ಸಿಜನ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರ್ತದೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, in the case of the V2O3 ಅಂತ ನೀವು ತಕೊಂಡ್ರೆ ಅಲ್ಲಿ here oxygen the most stable oxidation state is -2 into 3, total ಆಗಿ -6 ಆಯ್ತು. Therefore, the vanadium is the total plus 6. The total ಎರಡು vanadium ಇದೆ. Therefore, the oxidation state of the vanadium is a +3 ಅಂತ ಆಯ್ತು, +3 ಫಸ್ಟ್ ಕೇಸ್ ಅಲ್ಲಿ. ಅದೇ vanadium O5 ಅಂತ ನೀವು ತಕೊಂಡ್ರೆ it is a -10, it becomes a +10. Therefore, the vanadium in oxidation state ಬಂದ್ರೆ it becomes +5 ಆಯ್ತು. Then vanadium V2O4 ಅಂತ ಇದೆ. Here the oxidation state of the vanadium is +4 ಅಂತ ಆಯ್ತು, +4. The which one is higher? The V2O5 in which vanadium +5. The next this one is more acidic. The second one, then third one. Therefore, the correct order is V2O3 is less, V2O4 is less V2O5. Therefore, option number B is the correct. Okay, V2O5 ಗೆ highest ಬೇಕು, V2O5, then V2O3, then V2O4, then V2O3. Therefore, the order is like this. Therefore, the correct answer is option number B. The next, the correct decreasing order of stability of the following compound is, okay, decreasing order of the stability of the following compound is, ನೋಡಿ ಈ ಕಾಂಪೌಂಡ್ ಸ್ಟೇಬಲ್, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಟ್ ಕಂಟೇನ್ಸ್ ಎ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಆಯ್ತಾ, ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇದೆ. ಈ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಅನ್ನ ನಾವು ಸ್ಟೆಬಿಲೈಸ್ ಅನ್ನ ಹೇಗೆ ಮಾಡಬಹುದು ಅಂತ ಹೇಳಿದ್ರೆ ಆನ್ ದ ಬೇಸಿಸ್ ಆಫ್ ದಿ ರೆಸೋನೆನ್ಸ್ ಇಫೆಕ್ಟ್. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಲೋನ್ ಪೇರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆರ್ ದ ಪೈ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದ್ರೆ ಅದು ಡಿಲೋಕಲೈಸ್ ಆದಾಗ ಯು ಆರ್ ಗೆಟಿಂಗ್ ದ ರೆಸೋನೆನ್ಸ್ ಇಫೆಕ್ಟ್. ಈಗ ದ ಕಾಂಪೌಂಡ್ ಕ್ಯಾನ್ ಬಿ ಸ್ಟೆಬಿಲೈಸ್ಡ್ ಬೈ ದಿ ರೆಸೋನೆನ್ಸ್ ಇಫೆಕ್ಟ್. ಇನ್ ದ ಕೇಸ್ ಆಫ್ ದಿ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಐ ವಿಲ್ ಗೋ ಥ್ರೂ ಇಟ್. ನೋಡಿ, ನಾನು ಆಪ್ಷನ್ ನಂಬರ್ ಬಿ ಅನ್ನ ತಗೊಳ್ತೀನಿ. ದ ನೈಟ್ರೋಜನ್ ಇಟ್ ಕಂಟೇನ್ಸ್ ಎ ಲೋನ್ ಪೇರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್, ಇಟ್ ಕ್ಯಾನ್ ಬಿ ಮೂವ್ ಲೈಕ್ ದಿಸ್, ಮೂವ್ ಲೈಕ್ ದಿಸ್, ಮೂವ್ ಲೈಕ್ ದಿಸ್. Therefore, it can be stabilized by this carbocation. Okay, the positive charge. Then in the second case, ನೋಡುವ, movement. It cannot stabilize by this positive charge. In the first case ಅಲ್ಲಿ ನೋಡುವ, movement, but it cannot be delocalized, but it can be stabilized by this pi electrons ಇಂದ stabilize ಮಾಡಬಹುದು. Then in the ಈ ಕೇಸಿಗೆ ಬಂದ್ರೆ it can be stabilized by here also, then here also. Okay, there are three possibility, but completely delocalize ಆಗೋದು ಯಾವುದು? in the case of the molecule B. Therefore, B ಗೆ highest ಇದೆ. Okay, B option number C ಮತ್ತೆ D ಅಲ್ಲಿ B ಅಂತ ಇದೆ. Okay, therefore you can be directly eliminate this one and this one. ಇವ ಎರಡನ್ನ ನಾವು ಡೈರೆಕ್ಟ್ ಆಗಿ ಎಲಿಮಿನೇಟ್ ಮಾಡುವ. B is highest ಆಯ್ತು. The next, whenever you can go for the A and D. In case of the D ಗೆ ನಾವು ಬಂದಾಗ the positive charge can be stabilized by the NH2 group ಇಂದು ಸ್ಟೆಬಿಲೈಸ್ ಮಾಡಬಹುದು, ಹಾಗೆ ಪೈ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇಂದು ಸ್ಟೆಬಿಲೈಸ್ ಮಾಡಬಹುದು. Okay, therefore the second is D. Therefore, correct option for this one is option number C. That is a B is greater, D is greater than A, then C. The least one is in case of the C. The next, which of the following is correct order of SN1 reaction? SN1 reaction and correct order no. SN1 reaction, do you know that it can be formation of the carbocation or carbonium ion or carbocation formation ಆಗ್ತದೆ SN1 ಅಲ್ಲಿ. You can be, which of the following is correct order of SN1 reaction? ಯಾವುದರಲ್ಲಿ more familiar ಆಗಿರ್ತದೆ, which compound? Okay, ನಾವು ನೋಡುವ. Here ನೋಡಿ, ಒಂದು ಕಾರ್ಬೋಕ್ಯಾಟೈನ್ ಫಾರ್ಮೇಶನ್ ಆದ್ರೆ ಅದನ್ನ ಯಾವ ಕಾಂಪೌಂಡ್ ಅಲ್ಲಿ ಮೋರ್ ಸ್ಟೆಬಿಲೈಸ್ ಆಗ್ತದೆ? ಮೋರ್ ಸ್ಟೆಬಿಲೈಸ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಅಂದ್ರೆ electrons or the lone pair of electrons idre, it can be stabilize that carbocation or the positive charge. For example, illi ನಾವು ನೋಡಿದಾಗ all the above is remain the same, ಅಲ್ಲಿ ಏನು ಚೇಂಜಸ್ ಇಲ್ಲ. The below ನೀವು ಬಂದಾಗ NO2 ಇದೆ, OMe ಇದೆ, NH2 ಇದೆ. Here there is nothing is there. ಈಗ NO2 OMe NH2 ಬಂದಾಗ the nitrogen it contains a lone pair of electrons ಇದೆ. Okay, it can be stabilized by like this. Okay, whatever the positive charge is, it can be stabilized by like this. The oxygen also it contains a lone pair of electron, but here there is a OMe group, methyl group is there. But NO2 bandaga it is an electron withdrawing. It cannot be stabilized this carbocation. Positive charge anna stabilize madudilla. Here there is no group, it can be stabilized by itself. Aita benzyl carbocation itself. ಈಗ ನಾವು ಬಂದಾಗ in the third option ಅಲ್ಲಿ NH2 it contains a nitrogen, it contains a lone pair of electrons, it can be more stable whatever the formation of the positive charge or carbocation. Therefore the highest is in the case of the third option. For example, third here is there. Therefore you can directly eliminate option number A and option number D. ಈಗ third is highest, then first is there, first is not there. Therefore it is electron withdrawing group, ಹಾಗಾಗಿ ಈ ಆಪ್ಷನ್ ಆಗುವುದಿಲ್ಲ. Therefore option number C is also incorrect. Option number B ಗೆ ಬಂದಾಗ the highest is in case of the NH2, the second is in case of the OMe, then third one is a fourth option number 4. Then the least one is in case of the first because of the electron withdrawing group. Therefore the correct option is option number B. Option number B is the correct answer for this question. Next question. Okay, here XCF4, SF4 and BrCl3 show hybridization respectively. Okay, here I will tell one of the concept to find out the hybridization. You kaltidri in first year alli bandide aa formula ide. Okay, I will tell you one more time. That is, whenever any molecule, for example, it is like a binuclear molecule iddaga, you have to use the formula like for hybridization H is equal to half into V plus M minus C plus A. ಈ ಫಾರ್ಮುಲಾನ ನೀವು ಯೂಸ್ ಮಾಡಬಹುದು. ಓಕೆ, H is equal to half into V plus M minus C plus A. ಇಲ್ಲಿ H ಅಂದ್ರೆ ಏನು? It is a number of hybrid orbital. ನೋಡಿ, H ವ್ಯಾಲ್ಯೂ ಇಂದ you have to tell the what is the hybridization. For example, H ವ್ಯಾಲ್ಯೂ ಅಂತ ಹೇಳೋದು ನಿಮಗೆ 2 ಬಂದ್ರೆ ಅದು sp hybridization ಅಂತ. H value is equal to 3 ಅಂತ ಬಂದ್ರೆ it is sp2. ಅದೇ H value is equal to 4 ಅಂತ ಬಂದ್ರೆ it is sp3. ಅದೇ H value ಅಂತ ಹೇಳೋದು 5 ಬಂದ್ರೆ that is called as a sp3d ಅಂತ ಬರ್ತದೆ. ಅದೇ H is equal to 6 ಅಂತ ಬಂದ್ರೆ it is sp3d2 or d2sp3 like that. sp3d2 or d2sp3 like that. H is equal to 6. Okay, H is equal to 6. ಈಗ ನೋಡುವ, in case of the what is V anta? V anta helidre valence shell electrons of the central atom. Valence shell electrons of the central atom. Then M andre eno? The monovalent atom around the central atom. Monovalent. Single bond iruvanta element anta monovalent. For example, hydrogen is a single bond, halogen is a single bond, adalla the single bond, therefore monovalent atom. C andre cationic charge. For example, nimge kottantaha compound alli ಒಂದು ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇದೆ, ಕ್ಯಾಟಯಾನಿಕ್ ಚಾರ್ಜ್, ಅದಿದ್ರೆ ಅದನ್ನ ಏನ್ ಮಾಡ್ಬೇಕು, ಮೈನಸ್ ಮಾಡ್ಬೇಕು. ದಟ್ ಇಸ್ ನಿಮ್ಗೆ ಗೊತ್ತಿದೆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಅಂತ ಹೇಳಿದ್ರೆ ದೇರ್ ಇಸ್ ಎ ರಿಮೂವಲ್ ಆಫ್ ದಿ ಎಲೆಕ್ಟ್ರಾನ್, ಹಾಗಾಗಿ ಮೈನಸ್ ಮಾಡ್ಬೇಕು. ದೆನ್ ಎ ಅಂದ್ರೆ ಆನಯಾನಿಕ್ ಚಾರ್ಜ್, ಆನ್ ಅಯಾನಿಕ್ ಚಾರ್ಜ್, ದಟ್ ಇಸ್ ಎ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್. ಕಾಂಪ್ಲೆಕ್ಸ್ ಅಲ್ಲಿ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಇದ್ರೆ ಅದನ್ನ ಆಡ್ ಮಾಡಬೇಕು, ಅಂದ್ರೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನ ಆಡ್ ಮಾಡ್ತೀವಿ, ಹಾಗಾಗಿ ಲೈಕ್ ದಟ್. ಓಕೆ, ಈಗ ನೋಡುವ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ XeF4 ಅಂತ ಒಂದು ಕಾಂಪೌಂಡ್ ಇದೆ. H is equal to half into lose contact. ರೆಕಾರ್ಡಿಂಗ್ ಆಗ್ಲಿಕ್ಕೆ ಹೋಗಿ ಅಂತ ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ. ಕಂಟಿನ್ಯೂ ಮಾಡ್ತೇನೆ, ಅಲ್ಲಿಂದ ಕಂಟಿನ್ಯೂ ಮಾಡ್ಬೋದಲ್ಲ ಮೇಡಮ್? Okay, here in case of the XeF4, half into valence shell electron, for xenon ಅಂತ ನಾನು ತಕೊಂಡ್ರೆ, therefore the outermost shell it contains 8 electrons ಇರ್ತದೆ, plus m ಅಂತ ಹೇಳಿದ್ರೆ monovalent atom, that is a fluorine, it is a monovalent atom 4, therefore half into, there is no charge, ಹಾಗಾಗಿ 12 divided by 2 ಅಂತ ಹೇಳಿದ್ರೆ therefore you are getting the 6 ಅಂತ ಹೇಳಿದ್ರೆ therefore it has the hybridization is sp3d2. Okay, sp3d2 ಫಸ್ಟ್ ಇದು sp3d2 ಅಂತ ಬರ್ಬೇಕು, sp3d2. ಲೈಕ್ SF4 ಅನ್ನ ನೋಡಿ, SF4 H is equal to half into the sulfur ಅಂತ ಹೇಳೋದು, it can be coming under the oxygen family. ಆಕ್ಸಿಜನ್ ಫ್ಯಾಮಿಲಿಯಲ್ಲಿ ಔಟರ್ ಮೋಸ್ಟ್ ಶೆಲ್ ಅಲ್ಲಿ 6 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರ್ತದೆ, ಪ್ಲಸ್ 4, therefore you are getting the answer is 5 ಅಂತ ಬಂದ್ರೆ sp3d. then BrCl3 H is equal to bromine, outermost shell ಅಲ್ಲಿ 7, plus Cl3 is a monovalent atom plus 3, therefore here also you are getting the 5, therefore sp3d. Okay, like that you have to find out for any molecule ಗೆ ನೀವು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬಹುದು. ಲೈಕ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಬಂದ್ರೆ ಏನ್ ಮಾಡ್ಬೇಕು, ಮೈನಸ್ ಮಾಡಬೇಕು. ವಾಟ್ ಆರ್ ದ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್? ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಒಂದು ಬೆಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್ ನಾನು ಕೊಡೋದಾದ್ರೆ ಅಮೋನಿಯಂ ಅನ್ನ ಕೊಡಬಹುದು. ಅಮೋನಿಯಂಗೆ ಈ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡೋದಾದ್ರೆ ಹೇಗೆ, ಹಾಫ್ ಇಂಟು ದ ನೈಟ್ರೋಜನ್ ಇಸ್ ದ ಸೆಂಟ್ರಲ್ ಆಟಮ್, therefore into 5, ಪ್ಲಸ್ ಹೈಡ್ರೋಜನ್ ಎಷ್ಟಿದೆ, 4 ಇದೆ, ಪ್ಲಸ್ 4, ದೆನ್ ಪ್ಲಸ್ ಚಾರ್ಜ್ ಪ್ಲಸ್ 1 ಚಾರ್ಜ್ ಇದೆ, ಹಾಗಾಗಿ -1, therefore 5 plus 4 that is 9, -1 ಅಂತ ಹೇಳಿದ್ರೆ 8, therefore you are getting the divide by 2, that is 4, you are getting the sp3. ಅದೇ SO4 2- ಅಂತ ಬಂದಾಗ you can be add the -2 ಅಂತ ಇದೆ ಚಾರ್ಜ್, ಅದನ್ನ ನೀವು +2 ಮಾಡಬೇಕು, ಇಲ್ಲಿ +2. okay, like that you have to do. therefore the correct answer is option number C. The next, when a phenol reacts with bromine in a low polarity solvent, for example low polarity solvent ಅಂತ ನಾವು ತಗೊಳ್ಳೋದಾದ್ರೆ ಕ್ಲೋರೋಫಾರ್ಮ್ ಅನ್ನ ತಗೊಳ್ಳಬಹುದು, CaCl3, it is a low polarity, it produces as a major product. ನಿಮ್ಗೆ ಗೊತ್ತಿದೆ ನೋಡಿ, phenol it can be reacted with bromine in water ಅನ್ನ ನೀವು ಸ್ಟಡಿ ಮಾಡಿದ್ರಿ. bromine in water, the water is a more polar, therefore bromine in water ಅನ್ನ ನೀವು ರಿಯಾಕ್ಟ್ ಮಾಡಿದಾಗ ಫಿನಾಲಿಗೆ ಯು ಆರ್ ಗೆಟಿಂಗ್ ದ 2,4,6 ಟ್ರೈಬ್ರೋಮೋಫಿನಾಲ್ ಬರ್ತದೆ. ಅದೇ ನೀವು ಲೋ ಪೊಲಾರಿಟಿ ಸಾಲ್ವೆಂಟ್ ಅನ್ನ ಯೂಸ್ ಮಾಡಿದ್ರೆ, ಕ್ಲೋರೋಫಾರ್ಮ್ ಲೈಕ್ ಕ್ಲೋರೋಫಾರ್ಮ್ ಅನ್ನ ಯೂಸ್ ಮಾಡಿದ್ರೆ ಏನಾಗ್ತದೆ, ಯು ಆರ್ ಗೆಟಿಂಗ್ ದ ಓನ್ಲಿ ಒನ್ ಪ್ರಿಡಾಮಿನೇಟ್ ಪ್ರಾಡಕ್ಟ್, ದಟ್ ಈಸ್ ಪ್ಯಾರಾಬ್ರೋಮೋಫಿನಾಲ್ ಸಿಗ್ತದೆ. ಯು ಆರ್ ಗೆಟಿಂಗ್ ದ ಪ್ರಾಡಕ್ಟ್ ಇಸ್ ಪ್ಯಾರಾಬ್ರೋಮೋಫಿನಾಲ್, ಆಯ್ತಾ, ಪ್ಯಾರಾಬ್ರೋಮೋಫಿನಾಲ್ ಇನ್ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ದಿ low polarity solvent. Do you know that the reaction ನಿಮ್ಗೆ ಗೊತ್ತಿದೆ? okay, phenol ಅನ್ನ ತಗೊಳ್ಳಿ, react with the bromine in presence of the low polarity like a chloroform CHCl3, you are getting the product is parabromophenol. Okay, therefore the correct answer is option number C. The next, if the solubility of the AgCl in aqueous solution is 1.434 into 10 to the power of minus 3 molar, solubility and kottidru, yes, is 1.434 into 10 to the power of minus 3 molar. Then find the value of minus log of base 10 or log of KSP, that is base 10 only. ಇದನ್ನ ನೀವು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಅವರು KSP ಅನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಹೇಳಿದ್ದಲ್ಲ, ಮೈನಸ್ ಲಾಗ್ ಆಫ್ KSP ಅನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ. Where KSP is the solubility product of AgCl. Solubility product constant ಅಂತ ಕರಿತೀವಿ. Solubility product constant or solubility. First, ಈಗ AgCl ಅಂತ ಇದ್ರೆ AgCl in aqueous medium, it can be undergo the dissociation. Okay, in a dissociation, you are getting Ag plus in aqueous plus Cl minus in aqueous. Here, solubility of the Ag KSP anta helidre hege, KSP is equal to the concentration of the Ag plus into concentration of the Cl minus. That is nothing but adara concentration anna I can take as S into S. Okay, that is S is nothing but the whatever the solubility of the AgCl. The solubility of the AgCl avare kottidru 1.434. Therefore KSP is equal to S square ಆಗ್ತದೆ, S square, or KSP is equal to 1.434 into 10 to the power of minus 3 whole square. Therefore you have to calculate this is, you are getting the value is nearly 1.434 whole square is nearly the value is 2 into 10 to the power of minus 6 ಬರ್ತದೆ, minus 6, 2 into 10 to the power of minus 6. That is about the KSP. ಅವರು ಕೇಳಿದ್ದು KSP ಅನ್ನ ಕೇಳಿದ್ದಲ್ಲ, minus log of KSP ಅನ್ನ ಕೇಳಿದ್ದು. Okay, therefore minus log of KSP is equal to minus log of, okay, you can take it is a base 10 only, base 10, okay, base 10 KSP, that is 2 into 10 to the power of minus 6. 2 into 10 to the power of minus 6. 2 into 10 to the power of minus 6. Okay, 2 into 10 to the power of minus 6. Minus log of base 10, minus log of base 10, KSP is equal to minus log of base 10, 2 into 10 to the power of minus 6. ನೀವು ಇದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಲಿಕ್ಕೆ ನಿಮಗೆ ಗೊತ್ತಿದೆ. Do you know that how to simplify minus log of base 10, 2 into 10 to the power of minus 6? ಈಗ log ಅಲ್ಲಿ ಕೆಲವೊಂದು ಫಾರ್ಮುಲಾ ಇದೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ log of ಬೇಸ್ 10 ಅಂತವೇ ತಗೊಳ್ತೀನಿ, a ಇಂಟು ಬಿ ಅಂತ ಇದ್ರೆ, ಅದನ್ನ ಹೇಗೆ ಬರ್ಕೊಳ್ಬಹುದು, log of base 10 a plus log of base 10 b ಅಂತ ಬರ್ಕೊಳ್ಬಹುದು. Therefore that formula you can be used here. Therefore minus log of base 10 2 plus it become plus into minus, therefore it is a minus only. Therefore minus log of base 10 to the power of minus 6. ಇದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ, do you know that the value of minus log of base 10 2, log 2 value base 10 ನಲ್ಲಿ ಇದ್ದಾಗ ನಮಗೆ ಆಲ್ಮೋಸ್ಟ್ ಗೊತ್ತಿರ್ತದೆ, that is 0.3010. ಹಾಗೆ log 4 ಅಂತ ಹೇಳಿದ್ರೆ 2 to the power of 2, therefore 2 times of the log 2 ಅಂತ. Okay, like that you have to remember 2, 4, 8 ಅನ್ನ ಆ ತರ ನೆನಪಿಟ್ಕೊಳ್ಬಹುದು. Here minus log of base 10 2 ಅಂತ ಹೇಳಿದ್ರೆ minus 0.3010. Okay, minus ಇಲ್ಲಿ ಏನಾಗ್ತದೆ, here you can use the formula, ಇನ್ನೊಂದು ಫಾರ್ಮುಲಾ ಬರ್ತದೆ ಇಲ್ಲಿ, log of base 10, okay, log of base 10 10 to the power of x ಅಂತ ಈ ತರ ಇದ್ರೆ ಅದೇ ವ್ಯಾಲ್ಯೂ ಹೇಗೆ, x into log of base 10 10. log of base 10 10 ಅಂತ ಹೇಳಿದ್ರೆ ಏನು 1, therefore you are getting the answer is x. Okay, x here, therefore x is nothing but minus 6. minus into minus 6. Okay, minus 6. Therefore, minus 6 log of base 10 is that value is 1. Therefore, minus into minus 6. Therefore, here the final answer is minus into minus 6 is nothing but 6 minus 0.3010. ಅದೆಲ್ಲ ಬೇಡ ನಮಗೆ 6 minus 0.3 ಅಂತ ನೀವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ರೆ ಎಷ್ಟು ಆನ್ಸರ್ ಬರ್ತದೆ? You are getting the answer is 5.7. Therefore, the correct answer is 5.7. 5.7. You are getting the answer is 5.7. Okay, 5.7. If solubility of the AgCl in aqueous solution is 1.434 into 10 to the power of minus 3 molar, then find the value of minus log Ksp. You are getting the answer is 5.7. 5.7. The next. Consider the following combination of N, L and M values. The correct order of energy of the corresponding orbital for multi-electron species. ನಿಮ್ಗೆ ಗೊತ್ತಿದೆ ಈ N, L, M ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಾಗ ಹೇಗೆ ನೀವು their orbital corresponding orbital ಅನ್ನು ಹೇಗೆ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋದು ಅಂತ. ಇಟ್ ಈಸ್ ಜನರಲಿ ಯು ಕ್ಯಾನ್ ಯೂಸ್ ದ ನಿಮ್ಗೆ ಮೈನ್ ಆಗಿ ಬೇಕಾಗಿದ್ದು ಇಲ್ಲಿ ನೋಡಿ M is all are 0. The M is not required. Here you can be consider N ಮತ್ತೆ L ವ್ಯಾಲ್ಯೂ ಇಂದ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬಹುದು. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ N is equal to 3 ಆದ್ರೆ L is equal to 0 ಆದ್ರೆ ನೋಡಿ L is equal to 0 ಆದ್ರೆ ಅದು S ಆರ್ಬಿಟಲ್ ಅಂತ, L is equal to 1 ಆದ್ರೆ P, L is equal to 2 ಅಂತ ಹೇಳಿದ್ರೆ it is D, then L is equal to 3 ಅಂತ ಬಂದ್ರೆ it is F. Okay, it is F. Therefore L is equal to 0, first N is equal to 3, L is equal to 0 ಅಂತ ಹೇಳಿದ್ರೆ 3s ಆರ್ಬಿಟಲ್ ಆಯ್ತು, 3s ಆರ್ಬಿಟಲ್. then N is equal to 4, L is equal to 0 ಅಂತ ಹೇಳಿದ್ರೆ it is 4s ಆರ್ಬಿಟಲ್ ಆಯ್ತು. then N is equal to 3, L is equal to 1 ಅಂತ ಹೇಳಿದ್ರೆ 3 into L is equal to 1, that is a 3p orbital. then N is equal to 3 and L is equal to 2 ಅಂತ ಹೇಳಿದ್ರೆ 3d. therefore the highest energy ಇರೋದು 3d ಗೆ. therefore the correct order is 4th ಗೆ maximum ಇದೆ, 4th ಗೆ maximum 3d ಆದ ಮೇಲೆ next ಯಾವುದು ಬರ್ತದೆ? 3p or 4s? 4s it will come. The highest is this one, first one, second one, then third one, then fourth one. Okay, fourth one. Therefore the correct order is the 3d it will come for the fourth. Therefore highest is this one, 4. The next 2, second one, which one is second? That is N is equal to 4. Therefore the correct answer is option number B. Therefore 4, then 2, the next third, the least one is for 1. Therefore the correct answer is option number B. Statement 1. Freezing point of the solution decreases with the decrease in the amount of the non-volatile solute. Freezing point of the solution decreases with the decrease in the amount of the non-volatile solute ಅಲ್ಲ, increase. ನಾವು ನೋಡಿದ್ದೇವೆ the depression in the freezing point is a colligative property. What is colligative property? The property which can be depends only on the amount of the substance and which does not depends upon the nature of the solute particle. ಹಾಗಾಗಿ increase ಆಗಬೇಕು. Therefore statement 1 is wrong. Statement 2. Freezing point of the solution is less than that of the solvent. That is correct. Therefore the solution has a less freezing point because it is a depression in the freezing point and less than that of the solvent. Solvent ಗೆ compare ಮಾಡಿ solution freezing point ಕಡಿಮೆ. Therefore that is correct. Therefore statement 1 is incorrect but statement 2 is correct. Statement 2 is correct. Therefore option number C is the correct answer. The next. The number of unpaired electrons on cobalt in the complex ion COCl4 2 minus C is. Therefore it is a tetrahedral complex. Okay, tetrahedral complex. ಈ tetrahedral complex ಅಲ್ಲಿ ಯಾವ ತರ splitting ಅಂತ ನಿಮಗೆ ಗೊತ್ತಿದೆ. Therefore E level it can be coming down, then T2 level it can be going up. T2 level. Okay, E level and T2 level. Okay, it is like a Barry center ಅಲ್ಲಿ E level. Therefore here Cl minus ಅಂತ ಹೇಳೋದು it is a weak ligand. Therefore in this case Cl minus ಯಾವ ತರ ಕಾನ್ಫಿಗರೇಷನ್ ಆಗ್ತದೆ ನೋಡುವ. You have to go for it. E level and the T2 level, E level and the T2 level and the tetrahedral complex. Cobalt. Here the oxidation state of the cobalt is +2. The oxidation state is cobalt +2. Therefore 3d7. Therefore electronic configuration is a 3d7 4s2. Therefore it is a 3d7. 3d7. Then here E level and T2 level. The first electron come to the occupy here. The total agi 7 electrons ide. Therefore the first come and occupy here. The second. Then third one occupy here. Fourth, fifth. Then it can be start pairing here. Okay, in E2 level. E2 level pair aagtade. Therefore configuration is like E4 T2 3. T2 3 aagtade. E4 T2 3. Their electronic configuration is E4 and T2 3. T2 3. Hagagi this is a 3 orbital ide. It all contains the unpaired electron. Here the both orbital it contains electrons are paired. Therefore total number of the unpaired electron is number B, that is 3. Which of the following has 2 chiral centers? 2 chiral center iruvanta compound yaudu? 2 bromo 3 deuterobutane, 1 bromo 2 deuterobutane, 1 bromo 3 deuterobutane, like that. Okay. For example, butane anta helidre total number of the carbon atom is 4. Aita. Iga 2 bromo anta naan takondre 2 bromo and deutero 3 deutero. Okay. Butane like CH3, H, CH3. Okay. 2 bromo, 3 deuterobutane. Nodi. For example, this carbon atom, it can be bonded with 4 different groups or atoms. Okay. Therefore, both having the chiral carbon. Idu chiral carbon, idu chiral carbon. Therefore, option number A is correct. Ade, ulda example anna nodi. Ulda example, for example, 1 bromo anta bartade. 1 bromo, CH2Br. Nodi, it is not a chiral center. It is not a chiral center. Therefore, it contains only 1 chiral carbon bartade. But in case of the option number A, it has a 2 chiral carbon. The next, consider the following reaction. This is the reaction H plus under heat. What is the product obtained? What is the product obtained? Do you know that? First step alli yen agtade? Okay, I will write the reaction. Nodi, the first step, the reaction, cyclohexane ring with the CH3 group. Illi OH group ide, it becomes a protonated agtade. Protonated. Therefore, OH2 plus it becomes protonated. Then CH3. Then after that, removal of the OH2. Okay, the water molecule it can be removed. Your formation of the carbocation. Formation of the carbocation CH3 with the positive charge here. Then here CH3. Okay, it indicates that CH3. The next, the whatever the carbocation obtained here, it is a secondary carbocation. CH2, OH, CH2 plus. Therefore, it is a primary carbocation. It is not a secondary, it is a primary carbocation. Like a C, not CH2, it is CH plus. Therefore, correct. It is a secondary carbocation. It is CH, here hydrogen with positive charge. Therefore, it is a secondary carbocation. Do you know that the carbocation stability, secondary carbocation is less stable compared to that of the tertiary carbocation. Hagagi enaಗ್ತದೆ, the one of the CH3 group can be migrating here. Therefore, you are getting the compound is ಏನು ಸಿಗ್ತದೆ? You are getting the compound is CH3 with the CH3. Here there is a formation of the positive charge. ಆಯ್ತಾ, ಇಲ್ಲಿ CH3 ಇದೆ, positive charge create ಆಗ್ತದೆ. Then the whatever the water H2O, it can be going out in the reaction. It can again come and attack like a nucleophile like ಅಲ್ಲಿ ಬಂದು attack ಆಗ್ತದೆ. For this one, you are getting the product is cyclohexane ring CH3 OH. Therefore, the correct answer is option number A, CH3 OH here. Therefore, the correct is option number A. Which of the following is correct regarding minus I effect of substituent? Minus I effect ನಿಮಗೆ ಗೊತ್ತಿದೆ, minus I effect and plus I effect. Plus I effect ಇರುವುದು electron donating group ಇದ್ದಾಗ, minus I effect ಇರುವುದು electron withdrawing group ಇದ್ದಾಗ. For example, in this example ಅಲ್ಲಿ ನಮಗೆ ಕೊಟ್ಟಂತ ಎಲಿಮೆಂಟ್ ನೋಡಿ, n, here R is common, therefore n oxygen and fluoride is there, F minus is there. ನಮ್ಗೆ ಗೊತ್ತಿದೆ ನೈಟ್ರೋಜನ್, ಆಕ್ಸಿಜನ್ ಮತ್ತೆ ಫ್ಲೋರಿನ್ ಅನ್ನ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ the fluorine is more electronegative, the next oxygen, the next nitrogen. Here more electronegative means it has the ability to attract the shared pair of electron towards itself. ಅಲ್ಲಿರುವ ಎಲೆಕ್ಟ್ರಾನ್ ತನ್ನ ಕಡೆ ತಗೊಳ್ತದೆ. Therefore it has a more minus I effect. Minus I effect ಇಲ್ಲಿ ಜಾಸ್ತಿ ಇರ್ತದೆ. The next oxygen, next nitrogen. Therefore the correct answer is option number A ನೋಡಿ. The fluoride having the highest, then O with the R group, then Nr2. Therefore the correct answer is option number A, because of the, on the basis of the electronegativity. Electronegativity, you can tell the answer. Next, which of the following options contains the correct match? Least 1 and least 2. Adiabatic process, then isothermal, isochoric and isobaric. Okay, here adiabatic process ಅಲ್ಲಿ ಏನು, heat exchange is equal to 0, Q is equal to 0, adiabatic process. Isothermal ಅಂದ್ರೆ ಏನು, the constant temperature. Therefore A is equal to Q ಬರಬೇಕು. A is equal to Q ಅಂತ ಹೇಳೋದು only one option. Then B is equal to P. Then C is equal to isochoric means it is nothing but work done is 0. Isochoric, work done is 0, that is nothing but work done ಯಾವಾಗ 0 ಆಗ್ತದೆ ಅಂತ ಹೇಳಿದ್ರೆ the change in volume is equal to 0. Delta V is equal to 0 ಆದಾಗ work done is equal to 0. Then isobaric ಅಂತ ಹೇಳಿದ್ರೆ there is a delta P is equal to 0. Therefore the correct answer is AQ. Therefore option number A, AQ, BP, CS and DR, CR. Okay, therefore isochoric anta helidre change in volume of the system is equal to 0, delta V is equal to 0. Therefore the work done andre eno, the pressure into the constant, pressure into the change in the volume, that is work done. Therefore the correct answer is option number A. The next, which of the following lanthanide ions is a best oxidizing agent? Nodi, in case of the lanthanides ಅಲ್ಲಿ ನಮಗೆ ಗೊತ್ತಿದೆ the most stable oxidation state of the lanthanides is +3. Here they are asking about oxidizing agent. ನೋಡಿ, on the oxidizing agent ಅಂತ ಹೇಳೋದು it can be undergo the reduction ಆಗಬೇಕು. ಇದು ಏನಾಗಬೇಕು? It can be undergo the reduction. It can be oxidize some other element, ಇನ್ನೊಂದು ಎಲಿಮೆಂಟ್ ಅನ್ನು ಆಕ್ಸಿಡೈಸ್ ಮಾಡೋದು. ಒಂದು ರಿಡಕ್ಷನ್ ಆಗಬೇಕಾದ್ರೆ ರಿಡಕ್ಷನ್ ಆಗುವುದಂತ ಹೇಳಿದ್ರೆ ಏನು, ದ ಲೋವರ್ ಆಕ್ಸಿಡೇಷನ್ ಆರ್ ಹೈಯರ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಟು ದಿ ಲೋವರ್, ಹೈಯರ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಇದ್ದದ್ದು ಲೋವರ್ ಆಗುದು, ಲೋವರ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್. ಓಕೆ, ಹೈಯರ್ ಇದ್ದದ್ದು ಲೋವರ್. ಬಟ್ ಹಿಯರ್ ಲುಟೀಷಿಯಂ 2+ ಅನ್ನ ನೋಡಿ, or cerium 2+, cerium 4+, tin 2+. Therefore in all this case their oxidation state is a +2. ಅದಕ್ಕಿಂತ ಮತ್ತೆ ಕಡಿಮೆ ಆಗ್ಲಿಕ್ಕೆ ಆಗುವುದಿಲ್ಲ. Okay, it cannot possible to the lower oxidation state. It may be go for the higher oxidation state. Therefore lutetium 2+, cerium 2+ and tin 2+, ಈ ಮೂರು ಇದೆಯಲ್ಲ, A, B and D, it can act as a not oxidizing agent, reducing agent. It can act as a reducing agent. But in case of the cerium 4+, then it can be moved to the higher to the lower oxidation state, that is a oxidizing agent. Therefore it can be like cerium 3+, like a lower oxidation state. It can be come to the lower oxidation, the addition of the electron. Okay, therefore it is a reduction anta kariತೀವಿ, addition of the electron. It can be moved like 4+ to the +3. Therefore the correct answer is option number C, that is a cerium 4+. The enthalpy vaporization of the substance is 8400 joule per mole and its boiling point is -173. The entropy change of the vaporization is, this question is coming under the thermodynamics. ಹೇಗೆ ನಾವು ಎಂಟ್ರೋಪಿ ಮತ್ತು ಹೀಟ್ ಕಂಟೆಂಟ್ ಆಫ್ ದಿ ಸಿಸ್ಟಮ್ ನಡುವೆ ಯಾವ ತರ ರಿಲೇಶನ್ಶಿಪ್ ಇದೆ, ಡೆಲ್ಟಾ S is equal to Q by T. Q by T. Therefore, temperature they are given in the degree centigrade. You have to convert into the Kelvin ಗೆ convert ಮಾಡಬೇಕು. -173 plus 273 ಅಂತ ಹೇಳಿದ್ರೆ temperature is equal to 100 Kelvin. 100 Kelvin. Therefore, Q is equal to they are given 8400 divided by T is 100. Therefore, you are getting the answer is 84. 20 get cancelled. 84 joule per mole per Kelvin. That is the answer. Therefore, the correct answer is option number A. The next. A system absorbs 10 kilojoule of heat at constant volume and its temperature rises from 270 degrees centigrade to 370 degrees centigrade. The value of delta U is, okay, they are constant volume and temperature is 270 to 370 degrees centigrade. A system absorbs heat is they are given the Q and delta U. It is according to the first law of thermodynamics. You can be solve this problem according to the first law of thermodynamics. Do you know that delta U is equal to Q, okay, a system absorb, okay, of heat at constant volume and its temperature. Therefore, delta U is equal to Q plus W. But they are telling about the constant volume. As I told earlier, the volume is constant. That is a delta V is equal to 0. Change in the volume is equal to 0. The what is work done? Work done is equal to the pressure into the change in the volume. If it is 0, the work done is also 0. W is equal to 0. Therefore, W is equal to 0. Delta U is equal to Q. Delta U anta helidre Q. Therefore, the Q is 10 kilojoule. Therefore, delta U is also 10 kilojoule. Therefore, option number B is the correct answer. The next, the number of atoms in 3.2 gram of the oxygen gas are. Oxygen gas is nothing but the O2. Okay, do you know that? Iga, for example, oxygen O2 anta ನಾವು ತಕೊಂಡಾಗ 32. Okay, the molar mass of the O2 is 32. Here 32 gram anta helidre it is nothing but the 1 mole. The 1 mole of the any substance or the particles it contains. How many number of the particles are there? Okay, 1 mole of the substance it contains. The number of the particle is Avogadro's number, that is 6.02 into 10 to the power of 23. Okay, 6.02 into 10 to the power of 23. For example, 33.2 gram ige estu. You can be calculate this value. Therefore, X is equal to 6.02 into 10 to the power of 23 divided into 3.2 divided by 32. 1 times, 10 times. Therefore, you are getting the answer is 6.02 into 10 to the power of 22. Therefore, option number A is the correct answer. ಅದೇ ಫಾರ್ ಆಕ್ಸಿಜನ್ ಆಟಮ್ ಅಂತ ಕೇಳಿದ್ರೆ ಏನ್ ಮಾಡ್ಬೇಕಿತ್ತು? ಆಕ್ಸಿಜನ್ ಗ್ಯಾಸ್ ಆರ್ ಆಕ್ಸಿಜನ್ ಆಟಮ್, ಯು ಹ್ಯಾವ್ ಟು ಮಲ್ಟಿಪ್ಲೈ ವಿತ್ 2 ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ ಆನ್ಸರ್ ಅನ್ನ ಬರೀಬೇಕು. The total number of the electrons in 1 mole of the peroxide is peroxide ಅಂತ ಹೇಳಿದ್ರೆ O2 2 minus. For example, peroxide, hydrogen peroxide or sodium peroxide, molecular formula is Na2O2 or H2O2. ಹಾಗಾಗಿ peroxide ion ಅಂತ ಹೇಳಿದ್ರೆ O2 2 minus. For example, O2, here the total number of the that is nothing but the number of the electrons ಅಂತ ಇದೆ. For oxygen, single oxygen, it has 8 electrons. That is nothing but the atomic number of the oxygen is 8. ಅದೇ O2 ಅಂತ ಬಂದಾಗ 8 plus 8, the number of the electrons is equal to 16 electrons. 16 electrons. They are asking about the peroxide ion. Plus, there are 2 electrons, addition of the plus 2. That is 16 plus 2. Therefore, 18 electrons. Therefore, the question is the total number of the electrons in 1 mole of the peroxide ion. The 1 electron, it contains the the total number of the particles is equal to, that is Avogadro's number, N naught or Na, or 18 electrons is equal to, therefore 18 N naught. That is Avogadro's number. Therefore, the correct answer is 18 N naught. 18 N naught. That is Avogadro's number. Principal azimuthal magnetic quantum numbers are respectively related to the principal azimuthal and magnetic quantum number. Principal quantum number, it can be denoted by the symbol N, principal. Okay. Then azimuthal quantum number ಗೆ ಬೇರೆ ಬೇರೆ ಹೆಸರಿದೆ. Subsidiary quantum number ಅಂತೂ ಕರೀತಾರೆ. Okay, orbital quantum number. Okay, orbital momentum quantum number, that is, it can be denoted by the symbol L. Then magnetic quantum number, it can be denoted by the, that is a magnetic quantum number, it can be denoted by the symbol is MS or ML. Magnetic momentum quantum number ML. Then spin quantum number, it can be denoted by the MS. Here ML. Therefore, N is equal to, it is a whole number, 1, 2, 3, like that. But L value anta heludeno, it can be including minus L to plus L, including 0. 0. The total values of L anta bandaga ಎಷ್ಟು ಬರ್ತದೆ? 2L plus 1 values. But the highest value of L anta heludu N minus 1 ಆಗಿರ್ತದೆ. Then ML anta ಹೇಳಿದ್ರೆ, here the ML values, it is also minus L2 plus L. Here total values of, here in case of the L, okay, it is for the ML. Okay, ML. Okay, I write. There is a minus L2 plus L. The total values is 2L plus 1. Then here in case of the L anta helidre, therefore do you know that here the value is 0 ... N minus 1 values. It is for the ML. ML minus L2 plus L including 0. The total values of the ML is 2L plus 1 values. Nodi, ಈಗ for example, principal quantum number, azimuthal quantum number, it can be tell about the shape. Magnetic quantum number, it can be tell about the orientation. Therefore, the principal quantum number, it can be tell about the size and extent of the energy. Therefore, the correct option is option number A. Principal quantum number size, azimuthal shape, then magnetic quantum number orientation. The next, a body of mass 10 milligram is moving with the velocity of 100 meter per second. The wavelength of the de Broglie wave associated when it would be. Nodi, here you can use the formula lambda is equal to h by mv. Wavelength ಅನ್ನು ನೀವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. therefore h ಅಂತ ಹೇಳಿದ್ರೆ ಅವರ ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಿದ್ರು 6.63 into 10 to the power of minus 34 whole dividing by the mass of the 10 milligram anta kottidre. You have to convert into the gram. 10 into 10 to the power of minus 3. Then velocity, they can be given in meter per second. Therefore, you can be taken in meter per second only, the velocity. Now you can be substitute this one. Therefore, 6.63 into 10 to the power of minus 34. It is 10 to the power 3. 10 to the power of minus 3 get cancelled. Therefore, 6.63 into 10 to the power of minus 3, 34 meter. Therefore, the correct answer is, okay, 6.63 into 10 to the power of minus 34 meter. The next, KMnO4 may be reduced to Mn2 plus, Mn4 plus or Mn6 plus. This reducing property depends upon, do you know that? This KMnO4 anta heludu, it can be act as a good oxidizing agent or strong oxidizing agent in acidic, basic and neutral medium. ಅದೇ K2Cr2O7 ಅಂತ ಹೇಳುದು potassium dichromate ಅಂತ ಹೇಳುದು, it can be act as a oxidizing agent in acidic medium. ಹಾಗಾಗಿ ಮೂರು ಆಗ್ತದೆ. Therefore, ಇದೆಲ್ಲ ಯಾವುದರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರ್ತದೆ? pH ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ. Therefore, the correct answer is option number A, the pH of the solution. The incorrect statement about the interstitial compound. Do you know that what is interstitial compound? The small atoms like carbon, nitrogen, oxygen or hydrogen, it can be trapped inside the cavities of the D block elements are called as interstitial compounds. ನೋಡಿ ಅದರ properties, they retain metallic conductivity, they are chemically reactive, they are much harder than the pure metal, they have higher melting point than the pure metals or pure metallic substance or pure metals. Therefore, ನೋಡಿ, for example, in case of the titanium carbide, if example anna takondre, it is an interstitial compound. They are chemically reactive anta ide. They are chemically reactive. That is the incorrect statement. Actually, these are chemically inert agirtade. Therefore, incorrect statement is option number B. That is, they are chemically reactive. Coordination number and the oxidation state of the central metal ion in the complex iron pentacarbonyl R. Iron pentacarbonyl andre FeCO5. Iron pentacarbonyl. In case of the carbonyl compound alli, the oxidation state of the metal anta helode always 0 agirtade. 0. Oxidation state is 0 and their coordination number ಅಂತ ಹೇಳಿದ್ರೆ ನಮ್ಗೆ ಗೊತ್ತಿದೆ. ಒಂದು ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ ಆಟಮ್ ಇದ್ರೆ ಅದಕ್ಕೆ ಎಷ್ಟು ದ ಲಿಗ್ಯಾಂಡ್ಸ್ ಬಾಂಡಿಂಗ್ ಆಗಿರ್ತದೆ, ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಎಸ್ ಎ ಕೋಆರ್ಡಿನೇಷನ್ ನಂಬರ್. ಟೋಟಲ್ ಆಗಿ CO ಎಷ್ಟಿದೆ? 5 ಇದೆ. therefore the coordination number is 5 and the oxidation number is 0. therefore 5 and 0, coordination number 5 and oxidation number 0. Option number B is the correct. An excess of the AgNO3 solution is added to the 100 ml of 0.01 molar aqueous solution of the dichlorido tetraaqua chromium 3 chloride. ನೋಡು ಅದರ ಸ್ಟ್ರಕ್ಚರ್ ಅನ್ನ ಬರೆಯೋ ಒಮ್ಮೆ. ಓಕೆ, the central metal atom is chromium dichlorido tetraaqua water tetra. okay, chromium chloride Cl. okay, Cl. therefore it is a +3 oxidation state. okay, +3 here, it is a +1 +3 here, -2 therefore it is a +1. okay, +1 here, -1. okay, matching. okay, therefore actually the structure is like this: CrCl2 H2O4 Cl. here how many, the number of moles of the AgCl precipitated is anta ide aita. precipitated is ನೋಡಿ, ಇದಕ್ಕೆ ನಾವು ಸಿಲ್ವರ್ ನೈಟ್ರೇಟ್ ಅನ್ನ ಆಡ್ ಮಾಡಿದ್ರೆ this compound it can be react with silver nitrate. ನಮಗೆ ಗೊತ್ತಿದೆ silver nitrate is a confirmatory test for halides. okay, for example in case of the chlorides ಏನಾಗ್ತದೆ ಅಂತ ಹೇಳಿದ್ರೆ, the whatever the chlorine which can be present outside the complex ion, that is called as a ನಾವು primary valency and secondary valency anta kariತೀವಿ. the primary valencies are ionizable, secondary valencies are non-ionizable, like that. therefore it can be undergo the reaction with this one. you are getting the 1 mole of AgCl. 1 mole of AgCl. therefore the correct answer is okay, 0.01 molar solution of the dichlorido. The number of moles of AgCl precipitated, the number of moles of AgCl precipitated is, there is a 1, the number of moles. here you are getting the 1 mole of AgCl can be precipitated. okay, that is the same number. then the electronic configuration of the cobalt in COCN6 3- is the electronic configuration of the cobalt in COCN6 3- is. okay, for example here Cn- is a strong ligand. therefore here cobalt, the oxidation state is a +3. therefore it is a 3d6. the electronic configuration is argon, then 3d6. Here in case of it is a strong ligand and octahedral complexes T2G then Eg. the energy gap is more, therefore it can be T2G6 Eg0. therefore the electronic configuration is T2G6 Eg0. therefore actually this is the answer, the answer number B. therefore T2G6 Eg0. Ag0. Half-life of the first order reaction 10 minutes. The percentage of the reactant remaining after 50 minutes from the beginning. Nodi. For example, initially 100 ittu. The half-life avare helidru 10 minutes anta. 10 minutes adaga 50 aitu. Again 10 minutes, that is 20 minutes 25. Again 10 minutes, that is 12.5. Again 10 minutes, that is 6.25. Again 10 minutes, the total half-life 1, 2, 3, 4, 5, that is 50 minutes adamele 3.125. 3.125. Therefore, half-life of the first order reaction 10 minutes, the percentage reactant remaining is 3.125. Okay, remaining is 3.125. Therefore, option number C is the correct. The rate constant for the first order reaction is 60 per second. The time taken to reduce the initial concentration of the reactant to its 1/6, the value will be. Nodi, nimge gottide what is the rate constant? K is equal to 2.303 divided by T into log of base 10. Log of base 10 R naught by R. R naught by R. Nodi, ee formula nu tagolbodu. Otherwise, you can take another formula is like this. K is equal to 2.303 divided by T into log of base 10 A divided by A minus X antu ನೀವು ತಗೊಳ್ಬಹುದು. A divided by A minus X. ಇಲ್ಲಿ A ಅಂದ್ರೆ initial and X anta ಹೇಳಿದ್ರೆ reacted anta. X is nothing but the reacted. Okay, now you can use this formula. The rate constant of the first order reaction ಅನ್ನು ಅವರು ಕೊಟ್ಟಿದ್ರು. ನಾವು ಟೈಮ್ ಅನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. Therefore, T is equal to 2.303 divided by K. K value is 60. Okay, log of base 10. Initially is A ಅಂತವೇ ತಗೊಳ್ತೀನಿ. Then the time taken to reduce the initial concentration of the reactant to 1/16, the value will be 1/16. Andre the time taken to reduce the initial concentration andre ಎಷ್ಟು? X is the reactor, 1/16. Therefore, A divided by A minus A/16. A/16. Okay, A/16. Now you can be calculate this one. 2.303 divided by 60 log of base 10 A divided by 16 minus A, that is 15. A divided by 16 anta bartade. Divided by 16. 16 minus A minus X is the reacted, 1/16 reactant of its initial concentration of the reactant to its 1/16 value will be reduced. Therefore 15. Therefore A get cancelled. Therefore you are getting the answer is 2.303 divided by 60 into log of base 10 16/15. 16/15. Okay, 16/15. You have to calculate. Therefore you are getting the corresponding answer. Okay, idana calculate ಮಾಡಿ. Here you can log of base 10 16 divided by 15 ಅಂತ ಹೇಳಿದ್ರೆ 16. Okay, A divided by A minus X. X is the reacted anta. X is the reacted. The remaining is therefore A minus 16 by 1/16 of A. 1/16 of A. Therefore A minus A divided by 16. 16 minus A divided by 15. Okay, then you can get the corresponding answer. You can calculate this one. Okay, you can calculate this one. You are getting the corresponding answer. Then for a reaction PA plus QB to give the products, if the rate law expression is R is equal to K into A to the power of L B to the power of N, then here for example ಇಲ್ಲಿ P and Q ಅಂತ ಹೇಳೋದು it is about the molecularity ಆಯ್ತಾ, molecularity. And LM ಅಂತ ಬಂದಿದೆಯಲ್ಲ, it is for the order of the reaction, order ಅಂತ. ಓಕೆ, ಯಾವತ್ತು ಮಾಲಿಕ್ಯುಲಾರಿಟಿ ಅಂತ ಹೇಳೋದು ಆರ್ಡರ್ ಆಗಿರ್ಬೇಕಂತಿಲ್ಲ, ಆಗಬಹುದು, may or may not be. Therefore P plus Q may or may not be equal to L plus M. The next, butane nitrile is formed by the action of the potassium cyanide with butane nitrile. ನೋಡಿ, butane nitrile ಅಂದ್ರೆ ಏನಂತ ಗೊತ್ತಿರಬೇಕು. butane nitrile CH3 CH2 CH2 It is butanitrile. Butanitrile anta helidre idu. Okay. What is the general name of butanitrile anta helidre adra IUPAC name aita. IUPAC name is butanitrile. Butanitrile is the IUPAC name. IUPAC name. Adra general name is propyl cyanide. Nange butanitrile beku is formed with the action of the potassium cyanide with N-propyl chloride. N-propyl chloride. Nodi N-propyl chloride CH3 CH2 CH2Cl plus KCN. You are getting the product is this one. Okay, Cl can be replaced by the Cn group. Therefore, CH3 CH2 CH2 Cn. You are getting the product is this one. Then propene is allowed to react with the hydrogen iodide. The product is then treated with the CH3ONA to give a new product is. For example, propene CH3 CH double bond CH2 hydrogen iodide ಒಟ್ಟಿಗೆ treatment ಮಾಡಿ. It follows the Markovnikov's rule. The H comes to the here and I comes to the here. You are getting the product is CH3 CHI then CH3. Then it can be react with ಯಾವುದು CH3ONA sodium methoxide. ಏನಾಗ್ತದೆ O minus ಬರ್ತದೆ, come and attack to the here and it can be replaced this one. You are getting the product is CH3 CHOCH3 then CH3. You are getting the product is this one. Therefore, it is a isopropyl. This is isopropyl group. Isopropyl methyl ether. Therefore, the option number A is the correct one. The IUPAC name of e compound in IUPAC name. Nodi, ಒಂದು cyclic ring ಇದೆ, there is a alicyclic compound ಇದೆ, ಮತ್ತೊಂದು open chain compound ಇದೆ. ನೋಡಿ, in case of the open chain compound and alicyclic compound ಇದ್ದಾಗ, which one has a maximum number of the carbon atom, that one can be taken as a root word. ಅದನ್ನ root word ಆಗಿ ತಗೊಳ್ಬೇಕು. Okay, here it contains a maximum. Therefore, cyclopropyl. Okay, cyclopropyl can be taken as a root word. Therefore, the name of the compound is for example carbon number 1. ಅದಕ್ಕೆ OH group attach ಆಗಿದೆ, ಹಾಗಾಗಿ carbon number 1 OH. ಇದು ಯಾವ group? That is ethyl group. This is the ethyl group. Therefore, the name of the IUPAC name of this compound is 1-ethyl cycloprophenol. 1-ethyl cycloprophenol is the correct answer. 1-ethyl cycloprophenol. The next, an organic compound A gives turbidity immediately with the Lucas reagent. ನಿಮ್ಗೆ ಗೊತ್ತಿದೆ, the Lucas reagent ಯಾವ ತರ ಆಕ್ಟ್ ಆಗ್ತದೆ. The Lucas reagent, it can be react with tertiary alcohol. ಒಟ್ಟಿಗೆ react ಆದರೆ it gives the turbidity immediately. Immediate ಆಗಿ ಬರ್ತದೆ. Immediately. Therefore, in the given alcohol ಅಲ್ಲಿ ಯಾವುದು ಟರ್ಷರಿ ಆಲ್ಕೋಹಾಲ್ ಅಂತ ನೋಡಬೇಕು. 2-methyl propane 1-ol ಆಯ್ತಾ. therefore propane 1-ol ಅಂತ ಬಂತು. therefore 2-methyl. therefore it is not a tertiary. okay, ಉಳಿದದ್ದು ಸ್ಟ್ರಕ್ಚರ್ you can write it. 3,3-dimethyl butane 1-ol. 3,3-dimethyl butane 1-ol. it is also not a tertiary. 2-methyl 2-butanol. 2-methyl 2-butanol. ನೋಡುವ ಇದರ ಸ್ಟ್ರಕ್ಚರ್ ಅನ್ನು ನೋಡುವ. butanol ಅಂತ ಹೇಳಿದ್ರೆ total number of the carbon atom is 4. butanol 2-methyl 2-butanol. ಎರಡನೇ ಕಾರ್ಬನ್ಗೆ OH, then it has a 2-methyl group. therefore it is a tertiary carbon. CH3 CH2 CH3. it is a tertiary carbon. ಇದು tertiary carbon. therefore it gives the turbidity immediately. therefore option number C is the correct answer. The first and second dissociation constant of the weak dibasic acid ಅಂತ ಹೇಳಿದ್ರೆ their basicity is equal to 2. Basicity is equal to 2. Do you know that what is basicity? Basicity ಅಂತ ಹೇಳಿದ್ರೆ ನಮ್ಗೆ ಗೊತ್ತಿದೆ, ಒಂದು ಆಸಿಡ್ ಅಲ್ಲಿ ಎಷ್ಟು ರಿಪ್ಲೇಸಿಬಲ್ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಇರ್ತದೆ, that is called as a basicity. For example, in HCl the basicity is equal to 1. In H2SO4 the basicity is equal to 2. okay, in phosphoric acid, the basicity is equal to 3, like that. Therefore, it is a dibasic acids. 1 into 10 to the power of minus 5 and 5 into respect to the overall dissociation constant. Nodi, whether it is a dibasic or monobasic, the overall dissociation constant anta bandaga Ka is equal to the first dissociation constant into the second. Therefore, what is 1 into 10 to the power of minus 5? 5 into, therefore, you are getting the answer is 5 into 10 to the power of minus 15. 5 into 10 to the power of minus 15. Minus 15. Therefore, correct answer is option number C. Option number C. Which of the following act as an oxidizing as well as a reducing agent? Here, nodi, I will go through the direct answer. Nodi, sodium nitrate anta heludu oxidizing ಆಗ್ತದೆ, reducing ಆಗ್ತದೆ. Because in a sodium nitrate, the oxidation state of the nitrogen anta heludu, here it is a, here oxygen minus 6 ಆಯ್ತು, therefore plus 5. Okay, it is a plus 5. The nitrogen in oxidation state plus 5, it is a plus 1, total agi minus 5, therefore it is a plus 5. Therefore, in nitrogen anta heludu, do you know that in case of the nitrogen, okay, therefore it can be increases the oxidation state O3, therefore minus total minus 6 plus 5. Therefore, which of the following act as a oxidizing as well as a reducing agent? NaNO3 here plus NaNO3, therefore it is a oxygen minus 2 into 6 is minus 6 plus 1, therefore NaNO2 NaNO3 plus 5. The oxidation state of the nitrogen is a minus 6, then it is a plus minus 5, therefore it is. In case of the NaNO2, okay, you can go through the NaNO2. NaNO2, it is a minus 4, okay, minus 4, therefore it is plus 1, therefore the plus 1, here the nitrogen oxidation state is plus 3. Plus 3. Therefore, the correct answer is NaNO2, not NaNO3, NaNO2. NaNO2. Notice, here plus 3 is there. The maximum oxidation state of the oxidation, for example, in case of the, it can be act as a reducing agent. Reducing agent means it can be increase the oxidation number up to plus 5. Or it can be act as a oxidizing agent. Oxidizing agent, it can be decreases the oxidation number like minus 3 agbodu some cases, or it may be 0 also. It may be 0 also. Therefore, the correct answer is NaNO2, not NaNO3. Sodium nitrite. Sodium nitrite is the answer. But in this case, it has the oxidation number is plus 5. There is no increase in the oxidation number. There is no increase in the oxidation number, only the decrease in the oxidation number. Therefore, the correct answer is NaNO2. NaNO2. The oxidation number of the sodium in sodium amalgam is, sodium in sodium amalgam andre sodium in mercury. In sodium amalgam or any amalgam, the oxidation state of the metal is 0. The oxidation state of the metal is 0 agirtade. The next, limiting molar conductivity of sodium acetate and our kottidru, sodium acetate HCl and NaCl are 91.6, 425 and 125. First you have to calculate limiting molar conductivity. Molar conductivity 0.1 molar acidic acid they are given. You have to calculate the limiting molar conductivity and calculate madi. Limiting molar conductivity, for example, for acidic acid in a limiting molar conductivity anta helidare CH3COH. Therefore 91.6 sodium acetate plus HCl, that is a 425 minus 128.1. You have to calculate. First one, lambda m naught anna calculate madi. Okay, I will give the hint for this one. Okay, you have to this one, lambda m naught. Then after that, alpha is equal to lambda m divided by lambda m naught. Their degree of dissociation anta helidre lambda m divided by lambda m naught. Lambda m value avare kottidru, that is 7. divided by lambda m naught. Illi banda value and you have to substitute it here. Okay, you have to substitute it here. Therefore, you are getting the alpha value. Then you have to find out the dissociation constant. Hege find out ಮಾಡ್ತೀರಿ? Do you know that? Ka is equal to actually alpha is equal to square root of Ka by C. Ka by C, that is concentration, or Ka is equal to alpha square into C. Alpha square into concentration. Alpha square you have to find out here. Alpha square C value ಅವರು ಕೊಟ್ಟಿದ್ರು. The concentration is 0.1 molar. ಆಯ್ತಾ? Alpha square ಗೆ into 0.1 molar ಹಾಕಿದಾಗ you are getting the Ka value. Okay, it is clear now. First you have to find out the limiting molar conductivity of the acidic acid like this. Then alpha na calculate ಮಾಡಿ. Then you can go for the alpha is equal to square root of Ka by C. Ka is equal to alpha square into C. The next assertion, 1 coulomb of the electric charge deposit weight equal to the electrochemical equivalent of the substance. That is correct statement. Then 1 Faraday deposit 1 mole of the substance. That is wrong. For example, their gram equivalent mass of the solute. For example, Fe2 plus anta idre, it cannot be give the 1 mole. Okay, therefore 2 Faraday is required. Okay, therefore assertion is true, reason is false. Okay, therefore the assertion is true and reason is false. Then benzoic acid react to concentrated nitric acid and concentrated sulfuric acid to give. Nodi, benzoic acid andre eno benzene ring with COOH group. The COOH group anta helidre electron withdrawing group. Hagagi idanna neevu nitration madidre it is electron withdrawing group. You are getting the product is meta product. Okay, benzoic acid with metanitro benzoic acid. Therefore the correct answer is option number C, metanitro benzoic acid. The reaction of the ethyl formate with the excess of the methyl magnesium iodide followed by hydrolysis to give. Note ethyl formate, you have to write the structure of the ethyl formate. C double bond O, OC2H5. ಇದನ್ನ ethyl formate ಅಂತ ಕರೀತಾರೆ. ethyl then formate, ethyl formate. ಇದನ್ನ excess of the CH3MgI ಒಟ್ಟಿಗೆ react ಮಾಡಿದ್ರೆ ಏನಾಗ್ತದೆ ನೋಡು. The negative, it has a positive charge. It come and attack to the carbonyl center. Therefore it becomes, okay, you are getting the compound is HCOMgI, then here CH3, then OC2H5. Then again come and attack of the yavdu CH3MgI, that is excess of this methyl magnesium iodide, come and attack to the carbonyl center. Illi en ಮಾಡ್ತದೆ? Okay, therefore it can be remove the OC2H5 group. Okay, OC2H5 group. Therefore you are getting the compound is HCOMgI, then CH3. ಇದನ್ನ ನೀವು ಹೈಡ್ರೋಲಿಸಿಸ್ ಮಾಡಿದ್ರೆ it becomes OH ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗ್ತದೆ. It becomes the OH. Therefore you are getting the compound is secondary alcohol CH3CHOH. Therefore it is a secondary alcohol CHOH. Therefore you are getting the ethanol, propanol, isopropyl alcohol. Option number D is the correct, isopropyl alcohol. Tertiary amines have lowest boiling point amongst isomeric amines because, okay, ನೀವು tertiary amines ಅಂದ್ರೆ ಹೇಗಿರ್ತದೆ? R thrice N. Secondary amines ಆದ್ರೆ R twice NH. Primary amines ಅಂದ್ರೆ RNH2. ನೋಡಿ ಇಲ್ಲಿ ಫ್ರೀ ಹೈಡ್ರೋಜನ್ ಇದೆ, therefore it can be forms intermolecular hydrogen bonding ಆಗ್ತದೆ. ಆದರೆ in case of the tertiary amine there is no hydrogen, it does not form the hydrogen bonding or intermolecular hydrogen bonding. Therefore it having the lowest boiling point. They don't form hydrogen bond. Option number B is the correct. The correct IUPAC name of this compound is, nodi here in case of the amines The IUPAC name is one of the very important concepts. C2H5, then C2H5. Okay, here the one of the C2H5, CH3, the one of the C2H5 is can be taken as a root word. Root word agi takolbeku. Root word. The remaining is a substituent. Idu substituent. Idu substituent. In the substituent, E is coming first. Ethyl. Therefore, the name of the compound is N-ethyl, N-methyl, ethanamide. N-ethyl, N-methyl, ethanamide. N-ethyl, N-methyl, N-ethyl, N-methyl, ethanamide. That is the correct answer. Starting with 3 different amino acid molecules, the number of different tripeptide molecules are formed. Tripeptide starting with 3 amino acid, N is equal to 3. You can use the formula, the number of the different tripeptide for starting with N anta kotre, you can use the formula N factorial. Do you know that? What is N factorial? N into N minus 1 into ... into 3 into 2 into 1. You got 3 factorial. What is the 3? Amino acid. Therefore, 3 into 2 into 1, you are getting the answer is 6. Therefore, the correct answer is 6. Option number B. The incorrect statement about RNA, it does not undergo replication. It is a single strand. It contains only pyrimidine bases. Allah. It contains pyrimidine and purine bases also. Therefore, the incorrect statement is option number C. Option number C. Oxygen has lower ionization enthalpy than nitrogen and fluorine because oxygen. In case of the nitrogen anta bandaga namge, therefore 1s2, 2s2, 2p3, half-filled electronic configuration. Okay, half-filled. Ade fluorine ge bandre, it is the outermost shell, it contains 7 electrons. 2p5. 1s2, 2s2, 2p5. That is a 7 electron. Addition of the one more, it can be noble gas configuration. Therefore, its size is smaller than fluorine. Nitrogen is smaller. Its size is smaller. Okay. Here, nitrogen, fluorine is smaller, but nitrogen have stable configuration. It is a smaller in the size. Therefore, the correct option is fluorine is smaller, but nitrogen have stable configuration. That is a half-filled configuration. Okay. The next, the order of the covalent character of the alkali metals. For example, here size of the I is greater than that of the Br, then Cl, then F. If the size increases, the negative ions, for example, I minus, Br minus, Cl minus, if the size is bigger for this one, it has a more polarizability. The property like more polarizability. More polarizability. Therefore, the Mi having the more covalent character according to the Fason's rule. Now, nodidri the size of the anion anta heludu bigger irbeku, cation is smaller, and also large charge ratio. Therefore, in Mi, Br, Cl, Mf, therefore highest covalent character in case of the Mi because of the size of the halide ion. Why do elements in the same group have similar physical and chemical property? Here, because of the same electronic configuration. If the electronic configuration is the same, therefore it has the same physical and chemical property. For example, group number 1 anta bandre outermost only 1 electron, group number 2 like 2 electron, like that. Okay, therefore it has the same physical and chemical properties. The IUPAC name of the following alkane is, nodi. Here you can give the different way. Nodi, whenever on the IUPAC nomenclature bandaga, you can give the number in any direction. For example, top in the bottom bottom in the top or you can give the up to the down or left to the right, like that. But you must get the longest linear chain barbeko, and also the substituent must get the least number and the highest priority. Kadime number 1, 2, 3 kottaga kadime number barbeko, and it has highest priority. Therefore, here I will give 1, 2, 3, 4, 5, 6. Here I will give 7, 8 or 7, 8. Both are same. 7, 8. Notice second carbon having the substituent, third carbon having the substituent. Notice ನಾನು ಇಲ್ಲಿ ಕೊಟ್ಟಿದ್ರೆ 1 2 3 third carbon having the substituent ಬರ್ತಿದೆ. Therefore correct way of the numbering is this one. Okay, therefore the name of the compound is 2 methyl ide, 3 ethyl ide, then 6 ethyl ide. E is coming first. Therefore the correct name is 3,6 diethyl 2 methyl octane. 3 methyl 2 methyl octane. Therefore option number A is the correct answer. The last question. The increasing order of reduction of the alkyl halide with zinc and dilute HCl is. Nodi, in case of the alkyl halide iddaga, if the size of the halogen is bigger, idra bond weak agirtade. Idra bond is weak. This bond is weak. Okay. The Ri, alkyl group and iodide bond anta heludu weak agirtade because of the size of the. ನಮ್ಗೆ ಗೊತ್ತಿದೆ ಸೈಜ್ ಯಾವ ತರ ವೇರಿಯೇಷನ್ ಆಗ್ತದೆ. ಫ್ಲೋರಿನ್, ಕ್ಲೋರಿನ್, ಬ್ರೋಮಿನ್ ಅಂಡ್ ಅಯೋಡಿನ್. ದ ಸೈಜ್ ಇನ್ಕ್ರೀಸಸ್ therefore their bond strength ಅಂತ ಹೇಳೋದು ಡಿಕ್ರೀಸ್ ಆಗ್ತದೆ. therefore in case of the Ri it can be undergo the reduction is very easy. therefore here you are getting the product is alkane. ಆಯ್ತಾ, alkane product ಬರ್ತದೆ. reduction of alkyl halide with zinc and dilute HCl. You are getting the corresponding Rx can be converted to the RH. ಯಾವುದರಲ್ಲಿ ಈಸಿ ಆಗಿ ರಿಡಕ್ಷನ್ ಆಗ್ತದೆ? ಫಸ್ಟ್ Ri ಅಲ್ಲಿ maximum. Okay, the increasing order of the reduction Ri maximum, then RBr, then RCl. Therefore the correct answer is RCl, RBr, Ri. Therefore option number B is the correct answer. Okay, thank you. Okay, all the best for your CET or NEET or any competitive exams. Okay, thank you one and all.